Hello students. Today we are going to solve few questions on time and work. So these questions are mainly based on work is equal to efficiency into time. So mainly on the concept of work, right? Efficiency into time. If you want to practice all the questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Let's begin with question number 1. Two persons A and B can complete a piece of work in 8 hours and 16 hours respectively. If they work at it alternatively for an hour, A starting first, in how many hours will the work be finished? So students, again the question is based on, we'll mention the formula first. Work is equal to efficiency into time. Efficiency into time, right? It is given that two persons A and B can complete a piece of work in 8 hours and 16 hours respectively. So individually they take 8 hours and 16 hours to complete that work, right? So we'll consider W as the work, W as the total work. If A started doing that work, A takes completely 8 hours to complete that work, right? So time taken by A is 8 hours. Therefore, A's efficiency or A's 1 hour work, right? So work per unit time is called efficiency. So 1 hour work of A is equal to, so total work divided by time taken by A. So W by 8 is A's 1 hour work. Whereas B's 1 hour work. B's 1 hour work is equal to total work W by 16 hours, right? W by 16 is B's 1 hour. So if they start work at it alternatively for an hour, A starting first. So here A starts the work first, right, for 1 hour. Then in the next hour, B continues the work, right? So we'll consider A's one hour work plus B's 1 hour work at first, right? Later you can consider the remaining work, right? After 2 hours, again A will be continuing the work. Then B continues the work, like that. How many hours they take to finish that work, right? So here A's 1 hour work, A will be doing W by 8 amount of work in 1 hour, right? Plus B will be doing W by 16 amount of work in another hour, right? Therefore, in 2 hours, A and B together they will be doing, so here 16 is the LCM, 3W by 16 amount of work, right? So 3W by 16 amount of work will be done in 2 hours. This will be done in 2 hours, right? In first 1 hour, W by 8 amount of work, and in the next 1 hour, W by 16. Totally it is 3W by 16. What is the remaining work here? Remaining work, since W is the total work, W minus 3W by 16. So you have 13W by 16, right? 13W by 16 is the remaining work. So this remaining work can be written as 3W by 16 plus 3W by 16, right? Plus 3W by 16 plus 3W by 16. So it is 12W by 16 together. And lastly, it is W by 16. So together it becomes 13W by 16, right? In that, first 3W by 16 will be done by A and B in the third and fourth hour, right? In the next 2 hours, A and B will be doing 3W by 16 amount of work, right? And in the next 2 hours, right, A and B will be doing, right, 3W by 16 amount of work in the next 2 hours, right? Next, one more 3W by 16 amount of work will be done by A and B in another 2 hours, right? 3W by 16 amount of work in another 2 hours. And we have one more 3W by 16 will be done by A and B alternatively, right? In another 2 hours, 3W by 16. And lastly, we have W by 16. So last work will be done by A. Before that, B has done the work, right? So in the last hour, right, A will be doing W by 16 amount of work. So here, so A takes what amount of time, right? So here, time taken by A, therefore, time taken by A to do the last W by 16 work. Since work is efficiency into time, therefore time is equal to, so remaining work is W by 16 by efficiency of A, or 1 hour work of A, right? W by 16, since 1 hour work of A is, what is 1 hour work? It is W by 8, right? A's efficiency is W by 8, or 1 hour work of A is W by 8. So W by 8. So it becomes W and W will get cancelled. We have 8 by 16. So which is 1 by 2 hours. So A takes half an hour to complete the remaining work, right? Here, lastly, it is half an hour, right? Here the question is, in how many hours will the work be finished? What is the total time taken by A and B to complete the work? So A and B takes, both of them take 2 hours. First 2 hours, again 2 hours, plus 2 hours, plus 2 hours, plus 2 hours, right? 5 times 2 hours plus half an hour, right? Both of them take 10.5 hours, right? So therefore, total time taken is 10.5 hours, right? It is 2 plus 2 plus 2 plus 2 plus 2 according to our calculation, right? Plus half, it is 10.5 hours. So here option B is the right answer. Question number 2. Find the time taken by Shreya to complete the assignment if she has completed 2/3 of the part of it in 18 days. So 2/3 of the assignment, right? 2/3 of the assignment she had completed in 18 days, right? So we'll take assignment, the complete assignment as X, right? So we'll take 2/3 of X is equal to, right, has been completed in 18 days. Then what is the value of X? To complete the whole assignment, she takes 18 into 3 divided by 2 number of days, right? 18 into 3, 54 by 2 gives 27 days, right? So to complete the full assignment, she takes 27 days of time, right? Option D is the right answer. Whereas to complete 2/3 of the assignment, she takes 18 days of time. So what are the remaining days? 9 days are remaining, right? So in these 9 days, she completes the remaining 1/3 of assignment, right? Totally, she takes 27 days of time, right? Students, here we need to consider 2/3 of the assignment. And how do you relate this? To number of days. So 2/3 of assignment is equal to 18 days. That means to complete this amount of assignment, 2/3 of assignment, she takes 18 days of time, right? So we'll consider assignment part, whole part as X. Therefore, 2 by 3 into X becomes 18. Therefore, value of X is 27. Therefore, option D is the right answer. Question 3. 6 writers can write 6 poems with 6 pens in 6 hours. How long would it take 4 writers to write 4 poems with 4 pens? An easy question, students. Here, 6 writers can write, there are 6 writers, they can write 6 poems with 6 pens, in 6 hours, right? So that means one writer, we'll consider one writer, right? So he can write only one poem and he uses one pen in 6 hours. For each poem, each writer takes 6 hours of time, right? So there are 6 writers, they use 6 pens and they write 6 poems in the same duration, 6 hours, right? Here the question is, so how long would it take 4 writers to write 4 poems with 4 pens? Therefore, 4 writers, right? 4 writers So obviously they have to take 4 pens so that they can write 4 poems, right, in the same duration, 6 hours, right? Therefore, each writer, right, uses 1 pen. Each writer uses 1 pen. In 6 hours, he can write only 1 poem. Therefore, if there are 4 writers, they use 4 pens so that they can write 4 poems, right? And the time duration is same in 6 hours. So option B is the right answer. Question number 4. A can do a piece of work in 4 hours. B and C together can do it in 3 hours. While A and C together can do it in 2 hours. How long will B alone take to do it? Here, students, to solve this question, we are using the concept of work, right? Work is nothing but the product of efficiency and time, right? So efficiency of a person or efficiency of an object, whatever it is, right? Work is equal to efficiency into time. Here it is given that A can do a piece of work in 4 hours. So let us assume W be the amount of work here, right? So let us consider work is nothing but W, right? Here A can do a piece of work in 4 hours. Here work done by A is equal to efficiency of A, let it be EA, into he takes time which is 4 hours, right? So what is efficiency? Work done per unit time is called efficiency, right? For example, if A does 25 kilojoules of work in 4 hours, so then efficiency of A becomes 25 by 4, right? Work done per unit time, right? In unit time, what is the amount of work done by A is called is efficiency, right? So we'll consider efficiency of A in this case, right? Since total work is W, EA is taken as W by 4. Total work divided by time taken by A, right? So it is also given that B and C together can do it in 3 years. To complete the same work, W, B and C together can do it in 3 years. Therefore, we'll take efficiency of B plus efficiency of C, right, is equal to total work divided by time taken by them, right? So it is, W is nothing but total work done by B and C, which is the same work done by A in 4 hours, right? This is total work divided by time taken by them. Time taken by them, right? While A and C together can do it in 2 hours. So we'll consider efficiency of A plus efficiency of C, right? Can do it in 2 hours. W by 2. How long will B alone take to do it? So B alone can take, so the time to complete the W amount of work. What is the time we need to find, right? For that we need EB, right? So what is EB? Efficiency of B, right? So considering this as first equation, this as second equation, we just subtract second equation from first equation. 1 minus 2 gives, so that you can delete EC and EC, right? So 1 minus 2 gives EB minus EA is equal to W by 3 minus W by 2. Since EA, efficiency of A is total work by 4 hours, W by 4, right? This relation is already given. So EB minus W by 4, since A is W by 4, is equal to W by 3 minus W by 2. Therefore, EB is equal to W by 3 minus W by 2 plus W by 4. By taking LCM, so we have 12 as LCM, so that the number is divisible by 3, 2 and 4. So the respective numerators become, right? 3 into 4 is 12, therefore 4 into W is 4W minus 2 into 6, therefore it becomes 6W plus 4 into 3 is 12, therefore the respective numerator becomes 3W. So we have W by 12 as EB. What is EB? Efficiency, right? Efficiency of B. work done per unit time is called efficiency, is equal to total work done, right? Total work done by B divided by time taken by him, time taken by that respective person. Here it is B, right? So B takes 12 hours of time to complete W amount of work, right? That means B alone will take 12 hours of time, right? Therefore, option B is the right answer, right? So B takes 12 hours of time. How long will B alone can take to do it? So B will take 12 hours of time to complete the whole work, W amount of work. Hence, option B is the right answer. Question number 5. Anurag completes 2 by 13th work in 4 days. At the same rate, in how many more days will he finish the work? So we'll consider the total work as W, right? So total work is equal to W here. And he completes 2 by 13th work means 2 by 13th of the total work in how many days? In 4 days, right? And he completes the remaining work in how many days we need to find. What is the remaining work here? Right? In 4 days, if he completes 2 by 13th of the total work, remaining work becomes 1 minus 2 by 13th of work, right? Which is nothing but 11 by 13th of the total work is remaining work, right? How many days does it take to finish the remaining work? Let it be T, right? We all know that work is always efficiency is into time. Efficiency into time. Here efficiency is nothing but work per unit time. So per unit time means it may be 1 day, 1 hour, 1 minute, 1 second, right? So work done by that person per unit time is called efficiency. In other words, rate of work is taken as efficiency, right? So in 4 days, if he completes 2 by 13th of work, and it is given that at the same rate, that means with same efficiency, if he continues to do the work, in how many more days he will finish the remaining work? That's what the question is. Here, the important thing is at the same rate means with the same efficiency, right? So if it is given that at the same rate, we need to consider the efficiency of that person. Let us find efficiency, right? So in first 4 days, we'll consider the same concept. Work is equal to efficiency into time. So we'll consider 2 by 13th of work. What is 2 by 13th of work? It is again efficiency of that person into time taken by him, which is 4 days, right? Therefore, efficiency is equal to 2 by 13th of total work, which is W, right? Divided by 4 becomes denominator into 4, right? This is the efficiency of that person. And it is given that at the same rate, with the same efficiency, if he continues to do the work, right? So how many days he will take to complete the remaining work? We'll consider remaining work, right? Therefore, what is remaining work? 11 by 13th of total work is remaining work. So which is equal to, again, his efficiency, which is same, right? Which is same. So efficiency into time taken by him, which is capital T, right? But efficiency is, just now we had calculated, yes, 2W by 13 into 4 into T. So T is equal to, we need T here. So 11 into W into 13 into 4 divided by, so this denominator 13 into 2 into W, right? You can simplify. So 13 and 13 will get cancelled, W and W, 2 into 2 is 4. So 11 into 2 becomes 22, right? To complete the remaining work, he takes 22 days of time, right? So T is equal to 22 days. Given that, right, he continues to do the work or the remaining work with the same efficiency, right? If the efficiency is same, he can complete the remaining work in 22 days. So look at the options. Option B is the right answer. Question 6. 18 equally efficient workers can do a work in 12 days. They started working together, and after 4 days, 6 more equally efficient workers joined them. Then the remaining work will be completed in. So here, 18 equally efficient workers can do a work in 12 days means, so if you use a concept of work, it is always efficiency into time. Here, efficiency is nothing but number of persons who are working, right? So 18 workers, if they start doing work, right? 18 workers, they can complete the whole work in 12 days. Therefore, 18 workers into 12 number of days gives the total work, right? Total work. So what is 18 into 12? So 180 plus 36, 216 units will be the total work, right? So in reality, if they started working together, after 4 days, 6 more equally efficient workers joined them. We'll consider 4 days work, right? So how many workers are working here? 18 workers are working, right? Therefore, total work is equal to 4 days work, first 4 days work, plus last how many days they can complete the work totally in 12 days, right? Right? So 4 days work plus remaining days work. Remaining days work. We need to find these remaining days, right? So they started working together, and after 4 days, if 6 more persons join them who are equally efficient, then the remaining work will be completed in. So in how many days remaining work will be completed? That we need to find, right? Total work we already know, right? Which is 216 units is equal to, so what is 4 days work, right? So 18 workers, right? So they work for 4 days. So whole day's work becomes 18 into 4 plus remaining days work. So to the remaining work, 6 more efficient workers will join. 18 plus 6 workers into remaining days. Let it be T, right? So which is equal to 216 is equal to 18 into 4, 72 plus 18 plus 6, which is 24 into T, remaining days, right? So if 6 more workers had not joined the 18 workers, then the total time will be 12 days. Totally in 12 days, they can complete the work. But 6 equally efficient workers join, therefore they take less number of days, right? Therefore, so what is the remaining days we need to find? Therefore, 24T is equal to 216 minus 72. So which is equal to 144. So T is equal to 144 by 24, which is 6, right? So in 6 days, they can complete the work, right? Then the remaining work will be completed. In 6 days, the remaining work will be completed, right? Whereas in the remaining work, that means first part of the work, right, has been completed in 4 days. And second part of remaining work will be completed in 6 days. Totally, they take 10 days of time. But in the question, the remaining work will be completed in how many days is asked. Therefore, remaining work will be completed in 6 days. Right? Option B is the right answer. Question 7. 6 persons working 6 hours a day can complete a work in 12 days. When they have worked for 6 days, 2 persons left the job and the remaining workers started working for 8 hours a day. In how many days can the remaining work be completed? Here, students, so in ideal case, 6 persons working 6 hours a day can complete the work in 6 days. 12 days. Here, total work is equal to, so in this question also we are using the concept which is efficiency into time is equal to the work, right? Efficiency into time. Here efficiency is nothing but the number of persons working here, right? So 6 persons can complete a work in how many days? In 12 days. Therefore, so 6 persons into number of days are 12 days into time, right? But for each day, they work for 6 hours. Therefore, so 12 days into 6 hours gives the total time, right? Total time taken by how many persons? 6 persons to complete the total work, right? Therefore, it is 6 into 12 into 6. Therefore, 6 into 6 into 12, no need to simplify it. So, we'll simplify it later. 6 into 6 into 12 is the total work units, right? But in the given case, they have worked for 6 days. How many persons work for 6 days? So, 6 persons, right? So in first part, they have worked for 6 days, right? It is understood that for each day, they work for how many hours? 6 hours, right? After 6 days, 2 persons left the job. That means how many persons are working after 6 days? Only 4 persons are working, right? 2 persons left the job and the remaining workers started working for 8 hours a day. So remaining persons, they work for 8 hours a day, right? How many days can the remaining work be completed? To complete the remaining work, the second part of the work, how many days they will take? So let it be D number of days, right? And the total work is 6 into 6 into 12 units. Therefore, we can write total work, right? So we'll consider it as W is equal to first part of the work, which is W1. That means in first 6 days, right? The work done by 6 persons plus second part of the work, which is W2, right? Total work is 6 into 6 into 12, which is equal to W1. In first part of the work, 6 persons, they work for 6 days and each day they work for 6 hours. Therefore, first part of the work is 6 into 6 into 6 plus second part. In the second part, 4 persons work. Again, we are using the same concept, efficiency into time. Number of persons, 4 persons into D number of days they work and each day they work for 8 hours. Therefore, 4 into D into 8. Here we need to find the value of D, right? Simplify it. So 6 into 6 into 12 can be written as 6 into 6 into 6 into 2 minus, take this 6 into 6 into 6 to the LHS part. So we have 8 into 4, 32D in the RHS part. So we can write 6 into 6 into 6 is the common and 2 minus 1 gives 1 here is equal to 32D. Therefore, D is equal to 6 into 6 into 6 is 36 into 6, which is 216 by 32, right? So you can simplify it. So 8 into 4, then 8 into 2 is 16, then 8 into 7, right? So we have 27 by 4. 27 by 4 number of days. So to complete the remaining work, they take 27 by 4 number of days. Again, you can simplify 4 into 5, 20, 4 into 6, 24, 24 remain, yes, 3 by 4 days. 6 integer, 3 by 4 days. They'll take, how many persons take? 4 persons take, right? 6 integer, 3 by 4 days to complete the remaining work. Only the remaining work, right? So option D is the right answer. Question number 8. Working together, A, B and C can do a work in 3 integer 9 by 11 days. Whereas A and B together can do the same work in 4 integer 2 by 3 days. Find the time taken by C alone to do the same work, right? So we'll consider W as the total work. So we are using efficiency into time. The product of efficiency into time is total work, right? So A, B, C can do a work in 3 integer 9 by 11 days, right? So A, B, C means we'll consider efficiency of A, B and C together is equal to total work by number of days they are taking. They are taking 3 integer 9 by 11 days, right? Therefore, we'll consider efficiency of A, B, C, right? So we'll consider A plus B plus C. Together their efficiency is total work W by number of days taken by them. 3 integer 9 by 11 days. Right? So which is equal to W by, so 33 plus 9, which is 42 by 11 is their efficiency. Right? So whereas A and B together can do the same work in 4 integer 2 by 3 days. So we'll consider efficiency of A and B. Efficiency of A plus B. Sum of their efficiency is total work divided by number of days taken by them. 4 integer 2 by 3. So which is equal to W by, so 14 by 3. Right? 14 by 3. Just substitute the value of efficiency of A plus B. Right? So in the previous equation. Right? So efficiency of A plus B plus C is equal to, whereas efficiency A plus B is, right, 1 becomes, efficiency of A plus B is W by 14 by 3 plus efficiency of C. Efficiency of C is equal to W by 42 by 11. Right? Simplify it. Efficiency of C is equal to, so this becomes, RHS becomes 11W by 42 minus 3W by 14. Since 42 is the LCM, 14 into 3 is 42. So numerator becomes 11W minus 9W. Right? So we have 2W by 42 or W by 42 by 2, right? Which is 21. Efficiency of C is W by 21. Efficiency is nothing but total work by number of days, right? Total work by time. Time taken by whom? Time taken by C. Therefore, C takes 21 days of time to complete the total work, right? So according to the formula, efficiency is work by time. So efficiency of C is total work by 21, right? So C takes, so the question is find the time taken by C alone to do the same work. To do the same work, C takes 21 days of time. Option B is the right answer. Question number 9. A man walks a kilometer in B hours. The time taken to walk 200 meters is. So here man walks a kilometer in B hours. We'll consider speed of man. Speed is always distance by time, right? Distance by time. And he walks a kilometer in B hours, right? Therefore, his speed is A by B kilometer per hour, right? Here, time taken to walk 200 meters. Here, this distance is in terms of meters. Therefore, we'll consider distance covered by man in general, which is a kilometer in terms of meter, right? A into 1000, right? Meter by B hours, right? No need to convert the time here. So hours to minute or hours to second, because in the options we have the time in terms of hours, right? Therefore, speed of the man is 1000 A by B meter per hour. Meter per hour, right? So in the second case, time taken to walk 200 meters is. So speed remains same here, right? Therefore, his speed 1000 A by B is equal to distance by time, which is 200 meter by time taken by him, which is T, right? Because speed is same here, right? Therefore, simplify it, right? So we need time taken by him. T is equal to, so 200 B divided by 1000 A, right? So here 2 into 5 is 10. Therefore, B by 5A in terms of hours. Time taken by him to cover 200 meters is B by 5A hours. Right? Look at the options. Here option B is the right answer. There is a slight change in option B. Right? So, yes, B, it should be B by 5A hours. Option B. Question number 10. A cistern is filled by a tap in 3.5 hours. Due to a leak in the bottom of the cistern, it takes half an hour longer to fill the cistern. If the cistern is full, how long will it take the leak to empty it? So students will consider a cistern, and a tap can fill the cistern in 3.5 hours. 3.5 hours. In ideal condition, it takes 3.5 hours to fill the cistern. But due to a leak at the bottom, we will consider a leak at the bottom. This is tap. So we'll consider a leak at the bottom. So it takes half an hour longer to fill the cistern. Due to the leak, tap takes half an hour longer, right? That means, so tap takes 3.5 plus half, which is 4 hours to fill the cistern, right? So if the cistern is full, so how long will it take to take the leak to empty it? So what is the time taken by leak to empty the cistern? Right? So time taken by the leak to empty the cistern. So for that, we'll consider the ideal case. So in ideal case, time taken to fill the cistern, is 3.5 hours. Right? Whereas in the real case, time to fill the cistern is 4 hours. Time to fill the cistern is 4 hours. Right? So if you consider W as work to be done to fill the cistern, right? So here work to be done, work to fill the cistern as W, right? So we know that work is efficiency into time, or 1 hour work into time. Efficiency and 1 hour work both are same, right? Therefore, 1 hour work to fill the cistern is W by 3.5 hours. Right? Which is nothing but, so 3.5 means 7 by 2, right? So it is 2W by 7, right? So 2W by 7 amount of work will be done in 1 hour, right? In ideal condition, right? Whereas in real condition also, if work to fill the cistern is considered as W, right? 1 hour work will be here total work by time. Here time is different, 4 hours, right? So W by 4 will be 1 hour work in real condition, right? Therefore, here 1 hour work in ideal condition is more than 1 hour work in real condition. Because in ideal condition, there is no leak at the bottom. So more work will be done in 1 hour, right? Therefore, that difference in 1 hour work is nothing but 1 hour work of leak, right? Therefore, 1 hour work of leak is equal to, or hole is equal to, so work in real condition, it is W by 7. 1 hour work in real condition, which is 2W by 7 minus 1 hour work in real condition, it is W by 4. In ideal condition, it is 2W by 7. Since LCM is 28, numerators become, so 7 into 4, hence 2W into 4, which is 8W minus 4 into 7 is 28, hence W into 7, which is 7W. Right? So W by 28 is 1 hour work of leak. Right? According to concept, 1 hour work is total work by total time. Right? So total work by total time. Therefore, leak takes 28 hours of time to empty the cistern. Right? Right? So leak can empty the cistern, right? Here work done is emptying the cistern. Therefore, leak takes totally 28 hours of time to empty the cistern. Hence, option A is the right answer. Students, if you want to practice such questions on time and work, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question 11. A and B together can do a piece of work in 30 days. A having worked for 16 days, B finishes the remaining work alone in 44 days. In how many days will B finish the whole work alone? So an easy question, students. So let us assume the whole work to be done is 1 unit, right? Or 1. even you can take W as the total work. Total work as W, or 1. You can consider 1 as the whole work, right? So in that, A and B together can do a piece of work in 30 days. Therefore, A and B's 1 day work, B's 1 day work becomes, in 30 days they can complete the whole work. Therefore, their 1 day work becomes 1 by 30th of the total work, right? So if you take W as the total work, it becomes 1 by 30 into W becomes A and B's 1 day work. If you consider 1 as the total work, right, then 1 by 30 becomes their 1 day work, right? So we can write A plus B is equal to 1 by 30, right? And it is given that A having worked for 16 days, right? So if you consider 1 as the total work is equal to work done by A for 16 days. Since work is equal to efficiency into time, work done by A is equal to efficiency of A, right? A worked for 16 days, A into number of days, right? A's efficiency into number of days plus B's efficiency into number of days he worked is for 44 days, right? 16A plus 44B becomes total work. We have assumed 1 as total work, right? Therefore, we can write 16A plus 44B is equal to 1. But A plus B is 1 by 30. Therefore, here in the question, in how many days will B finish the whole work alone, right? Therefore, we have to consider the case for B here. Therefore, B is equal to, or so we'll consider A here. We'll express A in terms of B. A is equal to, or 1 day work of A. A in the sense 1 day work of A, or efficiency, both are same, right? Efficiency of A or 1 day work of A is equal to 1 by 30th, right? Minus 1 by 30 means 1 by 30th of the whole work minus B's efficiency, right? We'll substitute the value of A here. 16 into 1 by 30 minus B plus 44B is equal to the complete whole work, total work, right? Simplify it. So 16 by 30 minus 16B plus 44B is equal to 1. Minus 16B plus 44B. So it becomes 28B, right? 28B. Yes. 28B is equal to 1 minus 16 by 30. 1 minus 16 by 30 is, yes, 14 by 30. Right? 14 by 30. So B is equal to, so 14 by 30 into 28. So 14 into 2 is 28. So we have B as 1 by 60. Since 1 is the total work here, total work. So 60 is the time taken by B. So B takes 60 days of time. So 60 days of time. So in 60 days, B will finish the whole work, right? So if you consider W as the whole work, right? So these terms, 16B, 44B, so all these terms are in terms of W. That means into W, right? This part of 1 by 30 becomes 1 by 30th of the total work. It becomes into W, right? You will get the same answer. So at last you will get B as W by 60. Here W is the total work. 60 is number of days taken by B, right? Here B in the sense is efficiency, right? Therefore, option B is the right answer. Question 12. 6 boys and 11 men together can do some work in 7 days. Find in how many days 13 men together will do the same work if each boy takes thrice the time taken by a man to do the same work. So which is important here. Each boy takes thrice the time taken by a man. That means 3 boys, right? So capacity or efficiency of 3 boys is equal to efficiency of 1 man. Or 1 man is equal to 3 boys. right? So 6 boys and 11 men together can do some work in 7 days, right? So we'll take 6 boys plus 11 men. They can do some work in 7 days. Keeping this in our mind. So how many days do 13 men take? Therefore, 13 men take. 13 men is nothing but 11 men, right? Plus 2 men. How many days they will take? 11 men plus 6 boys take 7 days. 2 men is nothing but 6 boys because 1 man is equal to 3 boys, right? Therefore, 2 men is equal to 3 into 2, 6 boys. Therefore, instead of 2 men, we can write 6 boys. So 11 men plus 6 boys will take how many days? According to the question, they'll take 7 days of time. Therefore, 13 men also take same number of days, 7 days of time. Right? Therefore, option B is the right answer. This is the simplest method to solve this. Another method we'll consider, theoretical method, method 2. Right? 6 boys and 11 men together can do some work in 7 days. So we'll consider this question in terms of the concept of work, which is efficiency into time. Efficiency into time. Right? So how many days do 6 boys and 11 men take? They'll take 7 number of days. Right? If you consider W as the total work, right? 6 boys plus 11 men, 6b plus 11 men will take 7 number of days. Therefore, the total work W is equal to 6b plus 11m into 7. Right? So therefore, to do the same work, right, 13 men will take how many number of days? Given that each boy takes thrice the time taken by a man, right? Therefore, we'll consider 13 men into time, number of days is equal to the total work. Total work is equal to 13 men into how many number of days they'll take, right? Right? So given that 1 man is equal to 3 boys, right? We'll write 1 man is equal to 3 boys. How many number of days they'll take? So we have to write the total work is 6 boys plus 11 men, right, into 7 is nothing but 13 men into time taken by them. Both are same, right? Total work equal to total work. So instead of 3 boys, can we write 1 man? Or instead of 1 man, can we write 3 boys? Substituting this, right? Therefore, so 13 men is equal to 13 into 3 boys into time taken by them is equal to 6 boys, or else instead of 6 boys, you can write 2m also, right? So we'll go for that method only. It will be easy for us for calculation, right? Yes. 13 men into time taken by them is equal to 2 men. Instead of 6 boys, we are writing 2 men, right? Plus 11 men into 7. So 13 men into time taken by them is equal to 13 men into 7. So we can cancel 13 men and 13 men. So time taken by 13 men is equal to 7 days. Right? This is the theoretical method. Right? Using the concept of work is equal to efficiency into time. Here efficiency is nothing but number of persons, or work done by number of persons per unit time is called efficiency. Right? So 6 boys and 11 men. So this part is considered as their efficiency. How many people are working, right, per unit time is called their efficiency in simple words, right? So using this concept, we are solving in method 2, we will get the same answer. So option B is the right answer. Question number 13. 10 persons can empty 10-liter tank in 10 hours by using 10 buckets of equal size. Find how long will 7 persons take in order to empty 7-liter tank by using 7 buckets of equal size. Very simple calculations. So students, will consider 10 persons. 10 persons are using totally 10 buckets. 10 buckets of equal size, right? And they work for 10 hours. They work for 10 hours, right? To empty 10-liter tank. To empty 10-liter tank, right? Therefore, each person uses how many buckets? If 10 persons are using 10 buckets, therefore one person uses only one bucket, right? One person uses one bucket, right? But each person works for 10 hours, right? Here, one person doesn't work for only 1 hour. One person works for all 10 hours, right? So 10 hours, so then only he can empty 1-liter tank. If one person can empty 1-liter tank, 10 persons can empty 10 liters tank, right? Therefore, one person can empty 1-liter tank in 10 hours and he uses one bucket, right? Therefore, 7 persons. How many buckets can be used by 7 persons? So 7 persons use 7 buckets. For each person, 1 bucket means for 7 persons, 7 buckets, right? And each person has to work for 10 hours. Therefore, all 7 members, 7 persons, they work for 10 hours, right? To empty 7-liter of tank. If each person can empty 1-liter of tank like this, so 7 persons can empty 7 liters of tank, right? That's what the question. How long will 7 persons take in order to empty 7-liter tank by using 7 buckets? By using 7 buckets, 7 persons take 10 hours of time to empty 7-liter tank, right? Therefore, 7 persons take 10 hours. Option A is the right answer. Question number 14. A man is twice as efficient as a woman. Find the time taken by 29 women to do a work if 11 by 29th part of the same work is done by 6 men in 5.5 days. So students, it is given that one man is twice as efficient as one woman, right? So we can write one man is equal to 2 women. 2 women, right? So efficiency of one man is efficiency of 2 women, right? Therefore, it is given that work done by six men in 5.5 days is 11 by 29th part of the work, right? So we'll consider 6 men or efficiency of 6 men, right? Therefore, 6 men is equal to, if one man is equal to 2 women, 6 men is equal to 12 women. 12 women, right? So we'll consider work done by 6 men here, right? So work done by 6 men is equal to, so it is 11 by 29 part of the work, right? So done by 6 men in 5.5 days. Therefore, it is 6 men into 5.5. Right? Since work done by 6 men is 11 by 29 part of total work. So let total work be W, right? 11 by 29 point of 29 part of W is equal to 6 men into 5.5. See, but 6 men is equal to 12 women. So we can write 12 women into 5.5 is nothing but 11 by 2. Right? Therefore, here we need what is asked in the question, time taken by 29 women. Right? Before going to time, what is efficiency of 29 women we'll consider. Right? So to find that, we need what is the efficiency of 12 women. Right? Therefore, here 12 women's efficiency. 12 women is equal to, 12 women is nothing but their efficiency, right? So is equal to 11 by 29 part of total work. So this part, left hand side part, into, so it is divided by 11 by 2, it becomes a 2 by 11 into 2 by 11. So 11 and 11 will get cancelled here. So we have 2W by 29 is efficiency of 12 lumen. Right? Efficiency is nothing but work by time. Right? So if 12 lumen is equal to 2W by 29, what is the value of 29 lumen? Right? Therefore, 29 lumen is equal to. Right? So if 12 lumen is equal to 2W by 29. So 1 lumen becomes 2W by 29 by 12. Right? This is 1 lumen. Efficiency of 1 lumen. Therefore, 29 lumen into 29. Right? So this gives efficiency of 29 lumen. Right? So which is equal to, so 2W by 29 into 12 into 29. So that we can cancel 29 and 29. 2 into 6 is 12. So efficiency of 29 lumen is W by 6, where W is total work. Since it is efficiency is total work by total time taken. So 29 lumen take 6 days of time. Here the time is in terms of days. Right? So time taken by 29 women to do the remaining part, that is 11 by 29 part of the work done by 6 men. Right? So 11 by 29 part of the work done by 6 men is nothing but the part of work done by 12 women. Right? Therefore, so if 12 women can do some amount of work, what is work done by 29 women? Right? For that, we need efficiency of women. So 29 women can do W by 6 part of work. That means they take 6 days of time to complete W amount of work. Right? Therefore, the time taken by 29 women is 6 days. Option B is the right answer. Question number 15. Netra and Neha alone can do a work in 43 and 41 days respectively. They started working together, but Neha left on the starting of the 20th day. Then the remaining work was completed by Netra alone. Find the time taken by Netra to complete the remaining work. So students, so to complete some amount of work, Netra takes 43 days of time. Right? So we'll consider total work as W here. As W. If Netra takes 43 days of time to complete work, so what is her 1 day work? Right? So her 1 day work of Netra. 1 day work of Netra or her efficiency is equal to W by 43. Whereas 1 day work of Neha. 1 day work of Neha is equal to W by 41. Right? They started working together, but Neha left on the starting of the 20th day. So that means they started working together and they worked for 19 days. On the starting of 20th day, Neha left means Neha and Netra, they worked for 19 days. Right? For first 19 days, both of them worked together, Neha plus Netra. Right? So after 19 days, who left the work? Neha left the work. So Netra has to complete the remaining work. Right? So remaining work will be done by Netra. Here the question is, time taken by Netra to complete the remaining work. So what is the time taken by her to complete the remaining work? That we need to find. Right? For that, first we need to find what is the remaining work. Right? If total work is W and some amount of work has been done by Neha and Netra in 19 days. Let us find the work done in 19 days first. Right? Then what is the remaining work? Right? Then we'll find time taken to complete the remaining work. Right? So let us find Neha and Netra's 19 days work. Right? So their 1 day work is sum of their 1 day work. Right? So 19 days work done by Neha and Netra. right? Their 1 day work is W by 43 plus W by 41. This is their 1 day work. Into 19 gives 19 days work, right? So here LCM is 43 into 41. So 43 into 41 is equal to 1763 is the LCM. And the numerators become 41W plus 43W into 19. So their 19 days work becomes 84W by 1763 into 19, right? Is 1763 divisible by 19? No, not completely. We'll leave as it is, right? So 19 days work is this much, right? Equation 1. So what is the remaining work? We'll consider the remaining work. Remaining work is equal to total work W minus 19 days work. So 84W by 1763 into 19, right? So LCM is again 1763 and numerators become 1763W minus 84 into 19. You will get 84 into 19 as 1615, right? Sorry, not 1600. 1596. 1596. 1063W minus 1596W. Right? So here 1763 minus 1596. So you will get 167W divided by 1763 as the remaining work. Right? So this remaining work has been done by Netra alone. Right? What is time taken to complete the remaining work? Therefore, time taken to complete the remaining work, according to concept of work, work is 1 day work into time, right? Therefore, time taken is remaining work by 1 day work of, since remaining work has been done by Netra alone, so it is 1 day work of Netra. Right? So 1 day work of Netra is W by 43, right? So we'll substitute that value. Since remaining work is 167W by 1763 divided by 1 day work of Netra is W by 43. So we can cancel W and W. This 43 goes to numerator. So you will have 167 into 43 by 1763, right? So here 1763 can easily be divisible by 43, right? So you will get, yes, 43 into 41 as 1763. So you have 167 by 41 as time taken by Netra to complete the remaining work, right? 167 by 41, still you can simplify, right? So 167 by 41. 41 into 4 is 164 and 3 is the remainder. So 4 integer 3 by 41, right? Days. So Netra takes 4 integer 3 by 41 days. Option C is the right answer. To complete the remaining work, she takes 4 integer 3 by 41 days. Question 16. Neeraj takes 2 days more to do a piece of work that can be done alone by his brother in 10 days. How long they will both take to do the same work together? So students, we are using the concept of work, which is efficiency into time. Right? Here efficiency is nothing but work per unit time, or generally we'll consider it as 1 day work. Right? Unit time is nothing but 1 day. Right? In a per day, what is the amount of work done by that particular person is called as efficiency, right? Therefore, so here Neeraj takes 2 days more to do a piece of work, right? Let the work be W, right? So here we'll consider Neeraj as person A, right? And his brother as person B. Person B, right? So Neeraj take 2 days more. So what is the time taken by his brother? So his brother alone can do the same amount of work in 10 days, right? Therefore, so brother takes 10 days of time, right? 10 days of time to complete W amount of work, right? Therefore, 1 day work of his brother, 1 day work of B is equal to total work divided by number of days, W by 10, right? Whereas Neeraj takes, so how many days? 2 days more, right? Therefore, it is 10 plus 2, 12 days of time to complete the same amount of work. Therefore, 1 day work of Neeraj or efficiency of Neeraj is total work W by 12 days, right? So moving further, how long they will both take to do the same work together? So 1 day work of both Neeraj and his brother together, right? Therefore, if they work together, we'll complete. Yes, if they work together, so they'll complete their work in how many days they are asking, right? How long they will take to complete the same amount of work if they start working together, right? If they work together, their 1 day work, right? So 1 day work of A plus B, Neeraj and his brother. 1 day work of Neeraj and his brother is equal to total work by the formula. 1 day work is always total work by time, right? Or efficiency of both A and B, right? A plus B together, if they start working, their efficiency is equal to total work divided by time, right? So what is 1 day work of A plus B? 1 day work of A is W by 12 and his brother's 1 day work is W by 10 is equal to total work is W divided by time. Let it be T. We need to find the value of time here. Simplify it. So here LCM is 60, numerator becomes 12 into 5 is 60 plus 10 into 6. So it becomes 6W is equal to W by T, right? Therefore 11W by, take this W to the LHS part, is equal to 60 by T, right? W and W will get cancelled. So T is equal to 60 by 11, right? So 11 into 5 is 55. 5 is the remainder. So 5 integer 5 by 11 days of time they will take if they start working together, right? 5 integer 5 by 11 days is the answer. Hence option A. Question 17. A can finish a work in 18 days and B can do the same work in half the time taken by A. Then working together, the part of the same work they can finish in a day is. So here, so in a day, what is the amount of work done by A? So which is nothing but efficiency of A, right? So A is 1 day work. In other words, you can say. So for that, we use the concept work is always product of efficiency and time, right? Here efficiency is 1 day work. 1 day work. So here A can finish a work in 18 days, right? So we'll consider 1 day work of A. 1 day work of A is, so if you take W as the total work, right? So A can finish W by 18 amount of work in a day, right? In a day, A can finish 1 by 18th of total work. W by 18 means 1 by 18th of total work he can finish in a day, right? Whereas B can do the same work in half the time taken by A. So we'll consider 1 day work of B. 1 day work of B will be B takes half the time taken by A, means half of 18, which is 9, right? So 1 day work of B becomes W by 9. Total work by time taken is 1 day work, right? That means B takes or B completes 1 by 9th part of total work. W by 9 means 1 by 9th part of total work, right? So if they start working together, right, what is their 1 day work? So 1 day work of A plus B. A plus B indicates they work together. If they start working together, so their 1 day work becomes total work by time taken by them. Total work by total time taken by them to complete this total work, right? So according to the formula we are considering. So what is their 1 day work? Just add these two values, W by 18 plus W by 9. So sum of their 1 day work, right, is equal to total work is W, let T be the time taken by them, right? So simplify it. Numerator becomes W plus 2W and the denominator is LCM of 18 and 9, right, is equal to W by T. So here 3W by 18 is equal to W by T. So you can cancel W and W here. So T is equal to 18 by 3. So which is equal to 6, right? So the unit is days. So time taken by them, right, is that 6? 1 minute. So T is, yes, 18 by 3, which is 6 days, right? 6 days of time to complete. If they're working together, part of the same work they can finish in a day. So part of the same work means, right? So here T is equal to 6 days. Time taken by them is 6 days, right? To complete W amount of work, right? Therefore, so their efficiency is equal to W by 6. Efficiency of A and B is W by 6. Their 1 day work, if they start working together, is W by 6. That means they can complete 1 by 6th part of total work. Here they have not asked how many days they are taking to complete the total work, right? Here the question is what part of the total work they can finish, right? If they start working together. So if they start working together, they can finish 1 by 6th of total work, right? Therefore, 1 by 6th of total work, option D is the right answer. Question number 18. A can complete a work in 8 days, B in 16 days, and C in 10 days. They all started working together, but A had to leave work after 2 days, and B had to leave it after 4 days of the start. Find in how many days the work will be finished. So, students, for our convenience, we'll consider W as the total work, right? So, consider total work as W, right? It is given that A can complete a work in 8 days. So we'll complete the work. So for the first 2 days, all A, B and C will be working, right? So for 2 days, first 2 days, A, B and C, all the 3 persons will be working, right? They all started working together, but A had to leave work after 2 days. After 2 days, so only B and C are working. And they work for 2 days, right? B had to leave it after 4 days. So after 4 days means, so in the second part of the work, B and C are working, right, for 2 days. So after 4 days of the start, right, not after 4 days after first half, right, first part, not after the first part of the work, it is after the, right, the start. Therefore, so totally it becomes 4 days, right? B had to leave the work after 4 days of the start. Then the question is, find in how many days the work will be finished. So at last, only C will be working, right? In how many days? We need to find the time, right? We all know that work is equal to efficiency into time, E into T, where E is 1 day work, right? Work per unit time is called efficiency. We'll consider the first case, work done by A, B and C in 2 days, whereas work done by B and C in 2 days, whereas work done by C in last day, right? In how many days C can complete the remaining work? For that, we need remaining work done by C. To find remaining work, we need work done by A, B and C in the first 2 parts, right? So we'll consider first part in which work done by A, B and C. For that, we need their efficiency also, right? Their 1 day work. So we'll consider their 1 day work. So A can complete a work in 8 days. Therefore, A is 1 day work, right? So A's 1 day work becomes total work by number of days taken by A. W by 8 becomes 8 one day work. Along with A, B is also working, right? Therefore, plus B can complete the work in 16 days. Therefore, his 1 day work becomes W by 16. Plus C can complete the whole work in 10 days, right? Therefore, C's 1 day work becomes W by 10. Right? Therefore, their 1 day work becomes, since the LCM is 80, so numerator becomes 10W plus 5W plus 8W. So totally it is 23. It becomes 23. W by 80 becomes their 1 day work, right? But they work for 2 days, right? So we'll consider their 2 days work. Their 2 days work will be, so 2 into 23 by 80 of the total work, right? It becomes 23 by 40th part of total work, right? So A, B and C, they work for 2 days and they can complete 23 by 40th part of total work, right? Whereas in the next 2 days, B and C will be working, right? B and C. So their 1 day work, they work for 2 days. So we'll consider their 1 day work, then after their 2 days work. B's 1 day work is W by 16 because B takes 16 days to complete whole work. So his 1 day work becomes W by 16 plus C's 1 day work is W by 10. Since 80 is the LCM, so numerator becomes 5W plus 8W and it becomes 13W by 80. That means 13 by 80th part of total work can be done by B and C in 1 day. But they work for 2 days, right? So we'll consider their 2 days work. B and C's 2 days work becomes 2 times their 1 day work, right? Therefore, it becomes 13W by 40. So 13 by 40th part of the total work can be done by B and C in 2 days. The meaning is like that. So what is the remaining work? How to find the remaining work? Total work minus work done by A, B, C in the previous parts, right? Remaining work is equal to total work is W minus work done by A, B, C in first 2 days is 23 by 40 into W. 23 by 40th part of W minus in the next 2 days B and C can complete 30 by 40th part, right? 13 by 40th part of the total work. Therefore we can say 40 minus 23 minus 13, which is 36. So yes, 4 by 40th of the total work is the remaining work, or you can say W by 10. Remaining work is 1 by 10th of the total work is remaining work. Here the question is, find in how many days the work will be finished. So this remaining work will be done by C. In how many days? Again using the same formula, right? So time is equal to work by efficiency, right? What is the remaining work? W by 10 and efficiency of C. C can complete the whole work in 10 days. So C's efficiency becomes W by 10, right? W by 10. Therefore, so what is the answer? So time is equal to work by efficiency. Here, sorry, in how many days? So C completes the remaining work in 1 day. Yes, C completes the remaining work in 1 day. Here the question is, find how many days the work will be finished, the whole work, not only the remaining work, right? Here the question is, in how many days the total work will be finished, right? First part of the work will be finished in 2 days, first part, right? So what is the part? 23 by 40th of the work. And in the next 2 days, the 13 by 40th part of the work will be finished. Whereas in the last 1 day, the remaining part will be finished. So total time taken is 2 plus 2 plus 1, right? Totally, it takes 5 days to complete the whole work, right? It is not about part of the work. So the question is about number of days taken to complete whole work, not the remaining one, right? So taken to complete the whole work is 5 days, option B. Question number 19. Albela, Bob and Chulbul have to read a document of 78 pages and make a presentation the next day. They realize that the article is difficult to understand and they would require a teamwork to finish the assignment. Albela can read a page in 2 minutes and Bob in 3 minutes and Chulbul in 4 minutes. If they divide the article into 3 parts so that all the 3 of them spend the equal amount of time on the article, the number of pages that Bob should read is. So students, all of them together have to read 78 pages, right? Therefore, total pages to read is equal to, total pages to read is 78 pages. And they divide the 78 pages into 3 parts, not equally, right? So they divide the article into 3 parts so that they can spend equal amount of time on the article. So each of them will consider, each of them, let them spend t units of time, right? So each of them spend t time to read, right? It may be t minutes. Yes, t minutes of time to read. T minutes of time to read, right? Here the question is, the number of pages that Bob should read is. It is given even that. So here Albela can read a page of 2 minutes. In 2 minutes, he can read 1 page. Whereas in 3 minutes, Bob can read 1 page. Whereas Chulbul can read 1 page in 4 minutes. We'll consider that first, right? So here we'll consider them as A, B, C, Albela as A, Bob as B, Chulbul as C, right? So in 2 minutes, he can read 1 page. He can read 1 page. Therefore, in 1 minute, he can read 1 by 2, that is a half page. He can read half page. Whereas Bob in 3 minutes, he can read 1 page in 3 minutes. So we'll consider that. In 3 minutes, Bob can read 1 page. Therefore, in 1 minute, he can read 1 by 3 page. Right? Whereas Chulbul, in 4 minutes, he can read 1 page. 1 page. Therefore, in 1 minute, he can read 1 by 4 page. Right? 3 page. So in 1 minute, their 1 minute work is nothing but their efficiency. If you talk in terms of work, time and efficiency, work is efficiency into time. Their unit time work, 1 minute work is called their efficiency, right? And the article has been divided into 3 parts, right? So here, they are spending t minutes of time on the article, right? Therefore, what is their work in t minutes, right? So they can read here. Albela can read. Reading is nothing but work, right? So reading, or you can consider directly as work done by Albela. Since work is efficiency into time, right? Here, all of them are spending t minutes of time, and each person's efficiency is different, right? Efficiency means their 1 minute work is equal to half page. Albela can read half page in T minutes, right? And work done by second person Bob is 1 by 3 into again same time, and work done by third person Chulbul is 1 by 4 into T, and their total work is reading 78 pages, right? Therefore, so A's work plus B's work plus C's work is equal to, so 1 by 2T plus 1 by 3T plus 1 by 4T. So their total work is 78 pages, right? Reading 78 pages. You can take T as common. So 1 by 2 plus 1 by 3 plus 1 by 4, right? So here 78 is equal to T into, here LCM is 12. So 2 into 4, hence numerator becomes 4. 2 into 6 is 12. 3 into 4 plus 4 into 3. Right? Value of T becomes 78 into 12 by 13. So 13 into 6. So they take 72 minutes, right? Each of them takes 72 minutes, right? Here the question is how many pages that Bob can read, right? Bob can read 1 by 3 into T. He can do 1 by 3 into T amount of work. That means 1 by 3 into 72, right? Therefore, Bob can read 1 by 3 into T pages. Here, value of T is 72. So 1 by 3 into 72. So 3 into 2 is 6. 3 into 4. So Bob can read 24 pages. Right? 24 pages in T minutes. T minutes means in 72 minutes. Right? Therefore, option A is the right answer. Question number 20. So here students, there is a small error in the question. It should be 20 women, right? 20 women can do a work in 16 days. 16 men can complete the same work in 15 days. So what is the ratio between capacity of a man and a woman? Here capacity of a man means work done per unit time, work done in 1 day by a man, right? And work done by a woman in 1 day, right, is called their capacity, right? So in scientific terms, we call it as efficiency, their efficiency, right? We all know that work is nothing but the product of efficiency and time, efficiency into time, right? So it is given that 20 women can do a work in 16 days, right? So if we consider X as the total work, right? So X as the total work, to complete this work, right? 20 women work for 16 days. Therefore, total work can be written as 20 women into 16, right? Therefore, what is 20 women, efficiency of 20 women, right? So 20 women indicates the efficiency, into 16 indicates the time, right? So efficiency of 20 women is equal to total work X divided by number of days taken by 20 women, X by 16. Therefore, capacity of one woman, if 20 women having their capacity as X by 16, capacity of one woman becomes X by 16 into 20, right? So this 20 should be divided by, right? So the RHS should be divided by 20. Now consider the case of men, right? To complete the same work, 16 men work for 15 days. Therefore, we'll write total work X as 16 men, they work for 15 days, right? Therefore, capacity of 16 men or efficiency of 16 men is equal to X by 15. Efficiency in the sense their 1 day work, right? So in one day, 16 men can complete X by 15 or 1 by 15th part of total work, right? Therefore, capacity of one man, one man can complete, right? 1 by 15th part of total work divided by 16. So it becomes into 16 in the denominator part. Right? Here the question is ratio between capacity of man and a woman. So required ratio is capacity of man, which is X by 15 into 16, right? To woman, X by 16 into 20. So X and X will get cancelled. Then this 16 into 20 will go to numerator, because denominator of the denominator will go to numerator, and 15 into 16 will be the denominator, so that we can cancel 16 and 16. So we have 20 by 15 as the final answer. Required ratio is, yes, 4 is to 3, right? So 5 into 4 is 25 into 3. So required ratio is 4 is to 3. That means capacity of man to woman is 4 is to 3. Option C. Question 21. Rohan takes twice as much time taken by Sahil and Pulkit does it in the same time as Rohan and Sahil working together. If individually Rohan finished the work in 3 days, then the time taken by all three working together is. So let us understand the question first. Rohan takes twice as much time taken by Sahil and Pulkit does. So we'll consider Sahil and Pulkit and their work. Right? Work done by Sahil and Pulkit. So let the total work be W. As in the previous cases, here also we'll consider total work as W. Right? We know that W is equal to E into T, efficiency into time, or their capacity into time taken by them. Right? Here Sahil and Pulkit will consider their one day work. Right? So one day work of Sahil and Pulkit. So if they take T days of time, right? T days of time to complete the total work, their one day work becomes W by T. Right? I'll repeat. If they take T days of time to complete W amount of work, their one day work becomes W by T. Using W is equal to E into T, this relation. So just we are writing their one day work or their capacity, right? So here Rohan takes twice as much time taken by Sahil and Pulkit does. Therefore, one day work of Rohan simultaneously will take one day work of Rohan. He takes twice the time, right, taken by Sahil and Pulkit. Therefore, time taken by Rohan becomes 2 times T to complete W amount of work. Therefore, his one day work becomes, or his efficiency becomes W by 2T, right? So here, so in the same time, Rohan and Sahil working together, right? So if individually Rohan finished the work in 3 days, so Rohan can finish the work in 3 days. Therefore, so his one day work becomes W by 3 days. Totally, he takes 3 days of time, right? These 3 days is nothing but twice the time taken by Sahil and Pulkit, right? Therefore, what is the value of T? T becomes, yes, 3 is equal to 2T, right? 3 is equal to 2T. Therefore, T becomes 3 by 2, which is 1.5 days. So, this T is time taken by Sahil and Pulkit, right? Therefore, Sahil and Pulkit take W by 1.5, right? So, their one day work becomes W by 1.5. They take 1.5 days, 1.5 days to complete the work. Here the question is, if individually Rohan finishes the work in 3 days, then the time taken by all three working together. So we'll consider if all three of them, Sahil, Pulkit and Rohan, if they work together, right? If all three work together, together, their one day work becomes, so one day work of Sahil and Pulkit, right? So one day work of Sahil and Pulkit is W by 1.5 plus one day work of Rohan, which is nothing but W by 3, which is already given, right? Because he takes 3 days of time to complete whole work. So his one day work becomes W by 3 is equal to, right? What is their one day work? W by 1.5 plus W by 3. Here 3 is LCM. So 3W will be the numerator. So that we can cancel 3 and 3. So their one day work becomes the total work. That means they can finish the total work in one day. Right? If their one day work is total work, they can finish the total work in one day. Right? Therefore, come back to the question. The time taken by all three working together is, if all three of them work together, they take only one day to complete the whole work. So option A is the right answer. Right? Here in this question, students, first we need to find time taken by Rohan, right, to complete the whole work, which is already given. Rohan finished the work in 3 days. Therefore, his one day work becomes W by 3. And also it is given that he takes 2 times time taken by Sahil and Pulkit. Therefore, by formula it becomes W by 2T. So that we can equate 2T and 3. So time taken, T becomes 1.5 days, which is time taken by Sahil and Pulkit. Because 2T is time taken by Rohan, whereas T is time taken by Sahil and Pulkit. Therefore, their one day work becomes W by 1.5. If all of them work together, their one day work becomes 3W by 3, which is W itself. Their one day becomes the whole total work, right? Therefore, they take one day time to complete the whole work. Option A is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question 22. X and Y do a piece of work in 20 days and 12 days respectively. X started the work alone, and then after 4 days, Y joined him till the completion of the work. How long did the work last? So here, so for first 4 days, right, X started the work alone, right? So we'll consider 4 days work here, and X alone is doing his work for 4 days, right? So then after 4 days, Y joined him. So after 4 days, X and Y both are working, right? So to complete the work, so let the work be W here. To complete the total work, for first 4 days, X alone is working, right? After 4 days, X and Y together, they are working. How long did the work last? That means total time taken to complete the work need to be calculated. What is the total time? Not the second part time, right? Not after 4 days. Along with first 4 days, what is the total time taken by them to complete the work? That's what the question is. And it is given that X and Y to do a piece of work in 20 days and 12 days. Individually, they can complete their work in 20 days and 12 days. Using these information, we have to find the total time, right, if they work together. So here, so one day work of X we'll consider, right? One day work of X, right? Here also we are using the concept of work, which is efficiency into time. Here efficiency is nothing but one day work, right? So one day work of X is, if W is the total work, so total work by time taken by that particular person, right? So X takes 20 days of time to complete the work. Therefore, right, to complete one day work, right, or one day work of X is W by 20. Whereas one day work of Y becomes a total work W by 12. Right? Y takes 12 days to complete the work. Therefore, Y's one day work becomes W by 12. Right? X started the work alone. Right? So, for first 4 days, right? For first 4 days, X does his work, right? Therefore, so 4 days work of X, 4 days work of X becomes 4W by 20, right? And here after 4 days, X and Y, they continue their work. Y joins the work, right? Therefore, we'll consider total work as 4 days work. That means first 4 days work plus remaining work, right? Can we consider like this? Remaining work plus first 4 days work. First 4 days work is nothing but 4W by 20, which is done by X alone, plus remaining work, right, has been done by X plus Y, right? Since work is efficiency into time, X plus Y, it is their capacity into time taken by them, right? Into time taken by them, X plus Y into T. What is X plus Y? Right? Time taken by X and Y separately, right? So that means 1 day work, their capacity, right? Their capacity, X and Y are nothing but their individual capacity to work, right? So we'll consider their individual capacity as 1 day work of X and 1 day work of Y, right? Therefore, we'll substitute this value. 4W by 20 plus 1 day work of X. Just now we had calculated as W by 20. Of Y, it is W by 12 into time taken by them gives the remaining work. Simplified. Here the total work according to our assumption, it is W, right? Therefore, 4W by 20 is W by 5 plus here inside the bracket we'll simplify 20 into 3 and 20 into 5 is 60, hence 60 is the LCM. So numerator becomes 3W plus 5W into T is the total work. So W by 5 plus 8W by 60 into time, right? So we can take out W common. So 1 by 5 plus 8T by 60 is equal to W, so that you can cancel W and W. Therefore, so we'll take this 1 by 5 to the LHS part. It becomes 1 minus 1 by 5. Since LHS is 1, is equal to 8T by 60. Simplify it. 4 by 5 into 60 by 8 is equal to T. Right? 4 into 2 and 2 into 30. Yes. And 5 into 6. So T is equal to 6. What is T? Time taken by X and Y in the next part, right? T is equal to 6 days. Here the question is, how long did the work last? Means total time taken to complete the work is, so total time is 4 days, right, in the first part and 6 days in the last part. Therefore, total time, we have to consider the total time is 4 plus 6, which is 10 days. Right? Therefore, 10 days is the answer, right? So, option C. The work lasts for 10 days. Option C is the right answer. Question 23. A few children working together can do a piece of work in 18 days. If the number of children employed on the work is made double, how long would they take to complete half of the work, right? So here, few children working together, let the number of children be X, right? We'll consider number of children as X, right? So can do a piece of work in 18 days. Let the total work, right? Let the total work done by X number of children be W. Therefore, we can say work is equal to number of children X into number of days they are taking, which is 18 days. Since we are following the concept of work, which is efficiency into time, in this particular case, it is number of children, right? Their capacity, particularly capacity into time or efficiency into time. Here capacity is how many children are working here is considered as their capacity, right? So here capacity is X. In first case, it is X into number of days they are working, which is 18. This gives the total work. If the number of children employed on the work is made doubled. So in the second case, if number of children, right, is made double, means if it is 2x, right, how long would they take to complete half of the work? And work to be done is half of the work. That means half of total work, right? W by 2 or half of work. So how long would they take to complete? What is time taken by them? What is time, right? Therefore, half of work, which is 1 by 2 into W, is equal to number of children. In this case, to do half of the work, so twice the original number of children, right? So we require 2 times the number of children into time. So what is time taken by them, right? So half of work, what is work? Work is X into 18, right? Number of children into 18. Substitute that value, X into 18 by 2 is equal to 2 times, right? So 2 times X into time, right? Here the question is, how long would they take to complete half of the work? What is the time taken by them to complete half of the work, right? Therefore, so here 2 into 9 is 18. Therefore, 9x is equal to 2x into t. You can cancel x and x, right? T is equal to 9 by 2. So 2 into 4 is 8. 4 integer 1 by 2, right? Here the unit is days, 4.5 days, right? 4.5 days. So in the second case, when number of children, right, is equal to 2x. So number of children employed on the work is made double, which is 2x, and work to be done is half of the original work. Then time taken by them is equal to 4.5 days, right? 9 by 2 days or 4.5 days. Hence option A is the right answer. Question 24. A does 4 by 5 of a work in 20 days. He then calls B and they together finishing the remaining work in 3 days. How long B alone would take to do the whole work? Right? So here students, if we consider total work as W, so for 20 days, right, A alone does the work, right? A alone does the work for 20 days and he does 4 by 5 part of, right, of total work. If W is the total work, A does 4 by 5 part of work. Whereas after 20 days, he calls B, right? A and B together, they'll complete the work, remaining work in 3 days. What is the remaining work? If the initial work is 4 by 5 part of total work, remaining work will be 1 by 5th of total work, right? So total work minus 4 by 5 of total work gives 1 by 5 of total work, which is remaining, right? Therefore, so using this information, right, we are going to find time taken by B alone to complete the whole work. Right? So if B alone is doing that work, right, how many days he will be taking, right? For that, we'll consider the work done by A in 1 day, right? We all know that work is capacity or efficiency into time, right? Efficiency into time is called total work. Here efficiency is nothing but 1 day work, right? Therefore, first we consider 1 day work of A. 1 day work of A is equal to total work, right? Total work divided by time. So A takes how many days here, right? That we don't know. Here the total work To complete total work, how many days A is taking, we don't know. But to complete 4/5 of work, A takes 20 days. So instead of taking total work, we are considering 4/5 of total work. Right? To complete that, A takes 20 days of time. Therefore, his efficiency or 1 day work of A becomes 4/5 into W by 20. Right? Keeping this in our mind, so we'll consider 1 day work of A and B. Right? 1 day work of A and B. So which is A plus B is equal to after 20 days, right? So to complete 1/5 of work, which is remaining work, A and B take 3 days of time. Therefore, 1 day work of A and B becomes 1/5 into W whole divided by 3. Right? Here, what is 1 day work of A? Right? In the second scenario, A plus B we have taken. Right? So 1 day work of A is already 4/5 into W whole divided by 20 plus 1 day work of B is equal to, so this RHS part, right? W by 15. Right? Simplify it. So here B is equal to W by 15 minus, so this when you simplify it, 4W by 100. Right? Simplify it. Here 4 by 100 becomes 1 by 25. Since 150 is the LCM, so it becomes 10W minus 6W. Right? So B, in the sense 1 day work of B. 1 day work of B becomes 4W by 150. Right? Since numerator should be the whole work, W by 150 by 4. Right? Which is in the form of total work by time taken. Right? 1 day work of B is nothing but efficiency of B is work by time. Therefore, time taken by B alone is 150 by 4 days. Right? Here denominator indicates number of days they are taking. 150 by 4 in the sense 4 into 3, 4 into 7 is 28. 37 integer 2 by 4 number of days, or 37 integer 1 by 2 days. 37.5 days B will be taking, right, alone to complete the whole work. Therefore, option B is the right answer. Question number 25. A man, a woman, and a boy can do a work in 2, 3, and 6 days respectively. How many boys must assist a man and a woman to complete the job in 1/3 of a day? Students, here using the concept of work is equal to capacity into time, or efficiency into time, or number of persons into time, right? So here efficiency into time is work. Efficiency into time is work. Here efficiency is nothing but number of persons working here, right? So it is given that a man can do a work in 2 days, woman can do a work in 3 days, and a boy can do the same work in 6 days, right? So we'll consider man, a woman, and a boy, right? So they take 2, 3, and 6 days to complete a work. If W is taken as the total work, so their 1 day work. So in 1 day, man can do W by 2 amount of work. 1 day work is nothing but their efficiency, right? So 1 day work, that is efficiency or capacity, right? Work by time is their 1 day work. Total work is W. Total time is 2 days here. So 1 day work of a man is W by 2. 1 day work of woman is W by 3. Woman takes 3 days to complete whole work, right? So her 1 day work is W by 3. And boy takes 6 days. Therefore, his 1 day work is W by 6. Right? Here the question is, how many boys must assist one man and one woman to complete a job in 1/3 of a day? So we'll consider their 1/3 day work, right? So 1/3 day work. 1 day work is W by 2. 1 day work of man is W by 2. So 1/3 day work is W by 2 into 3 is 6. Right? So W by 2 into 1 by 3, which is W by 6. 1 day work of woman is W by 3 into 1 by 3, which is W by 9. Whereas 1 day work of boy is W by 6 into 1 by 3, which is W by 18, is 1 day work of a boy. Right? So here, to complete the total work, so one man, one woman, and n number of boys, they work for 1/3 of a day. Right? Therefore, we'll consider total work will be done by one man plus one woman work. Right? One man's work plus one woman's work plus n boys are required. N boys work. Right? That's what the question is. How many boys must assist to a man and a woman to complete the job in 1/3 of a day? Right? So one man's 1/3 day work it is. We have to consider 1/3 day work. Right? Therefore, we'll mention 1/3 day work of one man, one woman, and n number of boys. Right? 1/3 day work of one man is W by 6. Plus 1/3 day work of one woman is W by 9. So 1/3 day work of one boy is W by 18, but we require n number of boys. It becomes n into W by 18 and the total work is W. Here we require the value of n. How many boys are required, right? Simplify it. So here W minus W by 6 minus W by 9 is NW by 18. So simplify it. Since LCM is 18, so numerator becomes 18W minus 6 into 3, hence numerator becomes 3W. 9 into 2 is 18, so it becomes 2W is equal to NW by 18. So 18 and 18 will get cancelled. So we have 18 minus 5, which is 13. W is equal to NW. WW will get cancelled. So value of N is 13. So 13 boys are required to complete the total work in 1/3 of a day. Right? 13 boys are required. So option D is the right answer. Question number 26. A is twice as good a workman as B and thrice as good a workman as C. If C alone can do a piece of work in 24 days, how long would the three persons take to finish the work working together? If they start working together, so how many days the three persons will take, right, to complete the same amount of work, right? So this entire question is based on the concept of work, which is efficiency into time. Here efficiency is nothing but 1 day work. 1 day work is called efficiency. Since time is in terms of days, so work per unit time is called efficiency, right? So 1 day work of a person, unit time is 1 day here. Therefore, work done by that particular person per unit time is called as efficiency, right? So here A is twice as good a workman as B. So if you consider A as efficiency of A, person A, so A is equal to 2 times B. That means A is twice, that means 2 times efficient than B, right? Now, thrice as good a workman as C. And also A is equal to 3 times C. 3 times efficient than C. Right? So if C alone can do a piece of work in 24 days. So if W is the total work, so we'll consider total work as W, right, is equal to, so it is done by C, that means efficiency of C is efficiency of C, right, in 24 days. Efficiency into time gives the total work, right? Therefore, here total work W is equal to efficiency of C into 24, right? Right? So, here A is equal to 2B, whereas A is equal to 3C, right? What is the value of C? C in the sense efficiency of C is equal to W by 24. So total work divided by number of days gives efficiency of C. Right? Therefore, C is equal to W by 24. Therefore, A becomes 3 times W by 24. Right? Efficiency of A is 3 times total work divided by 24 days. Right? Whereas B becomes, here B is A by 2. Right? A is 2B, therefore B is A by 2. So what is A? 3 times W by 24 by 2 means denominator will be multiplied by 2. Right? Therefore, efficiency of B becomes 3W by 48. Efficiency of A is 3W by 24. Of C is W by 24. Why do we need efficiency? Because, so consider the last part of the question. How long would the 3 persons take to finish the work if they start working together? If they start working together, so we'll consider their 1 day work. What is 1 day work? Their efficiency, right? Here C, efficiency of C in the sense 1 day work of C. Efficiency of A means 1 day work. In general terms, we call it as 1 day work, right? So if all of them start working together, right? So if we'll mention it, if they start working together, we'll consider their 1 day work. So A's 1 day work is A, plus B's 1 day work is B, plus C's 1 day work is C. So A plus B plus C gives, right, their 1 day work. Together, if they start working, so their 1 day work becomes A plus B plus C, right? So their 1 day work becomes A plus B plus C, which is equal to, since A is 3W by 24, plus B is 3W by 48, plus C is W by 24, right? Since 48 is the LCM, so numerator becomes, so 3W into 2. Since 24 into 2 is 48. 3W into 2 becomes 6W. Plus next numerator is 3W itself. Plus since 24 into 2 is 48. So W into 2 becomes 2W. Am I right? So 3W, yes, 48 is the LCM. Therefore, so their 1 day work, A plus B plus C, is equal to, so 6 plus 3, 9 plus 2, 11W by 48. Right? So here 1 day work is always, according to the formula, 1 day work is always total work by time taken. 1 day work or efficiency is total work by time taken according to the formula. Here we'll express the numerator in terms of W. That means total whole W divided by denominator becomes 48 by 11. Right? Both are same. 11W by 48 is equal to W by 48 by 11. Right? Where W is total work, 48 by 11 is time. Right? Therefore, time taken by them, if they start working together, is equal to 48 by 11. Here the unit is days. Can still simplify. So 11 into 4 is 44. So 4 is the remainder. So 4 by 11. 4 integer, 4 by 11 days. Right? Is the time taken by them if they start working together. So option C is the right answer. Question 27. X and Y can do a work in 12 days and 16 days respectively. Both worked for 3 days and then X left the work. In how many days Y alone can complete the remaining work? Very easy question, students. This question is also based on the concept of work, which is efficiency into time. Right? Here X and Y together, right, they worked for 3 days. Right? We'll consider 3 days. Right? X and Y together, they will work, and after 3 days X left the work. That means Y alone has to complete the total work, right? If W1 is the first part of the work, right, in 3 days, right? So work done in 3 days is W1. W2 is work done after 3 days by Y, right? Therefore the total work becomes W is equal to work done in first part, which is W1, plus work done in the second part, which is W2. Here, what to be calculated here? How many days Y alone can complete the remaining work? So Y takes how many days to complete the remaining work, right? So we need to find time taken by Y. Time taken by Y to complete the remaining work, right? So here, if we consider W as the total work, W1 and W2 as the two portions of work, right? So we'll take W1, first portion of work, right? Here, X and Y together, they complete W1 work in 3 days, right? According to the concept of work, which is always efficiency into time. Efficiency is nothing but 1 day work, right, of a person. So here W1 can be taken as 1 day work of X and Y, so which is X plus Y, into time taken by them to complete W1. So which is X plus Y into 3, whereas W2 work has been done by Y, right? So 1 day work of Y into how many number of days? Time taken by Y. Right? We need to find this time, right? So for that, we need the value of X and Y. So what is X? 1 day work of X, right? So we'll consider that. So here it is given that X and Y can do a work in 12 days and 16 days respectively. So here, if X is efficiency of X or 1 day work of 1 day work of X, then X is equal to total work W by time taken by X is 12 days. And also, if Y is 1 day work of Y or efficiency of Y takes how many days? 16 days to complete W amount of work. Therefore, their respective efficiencies will be W by 12 and W by 16, right? So, efficiency in the sense of 1 day work, right? So here substitute the values of X and Y here. So since X is W by 12 and Y is W by 16 according to the given question. So into 3 is first part of the work plus Y. Y is W by 16. Y is 1 day work into total time taken by Y. Let it be T. Right? Here T is time taken by Y to complete remaining work, not the total work. Right? Simplify it. So LHS is W. Since LCM is 48, 16 into 3, 12 into 4, right? Therefore, the numerators become, so 12 into 4, W plus 16 into 3 is 48. Into 3 plus W by 16 into time taken by Y, right? So it becomes 7W by 48, 7 into 3, which is 21. So directly we'll write it as 21 W by 48 plus W by 16 into T, right? So we need T here. For that, we'll consider W by 16 into T is W minus 21 W by 48. Since 48 is the LCM, numerator becomes 48 minus 21, which is 27 W, right? So we'll find the value of T. So 27 W by 48 into 16 divided by W. W will get cancelled. 16 into 3 and 3 into 9 is 27. Therefore, so value of T is 9 days, right? So T is 9 days. What is T? Time taken by Y to complete the remaining work. So which is 9 days. Therefore, option D is the right answer. Question 28. A can do a piece of work in 40 days. He starts working, but having some other engagements, he drops out after 5 days. Thereafter, B completes this work in 21 days. How many days would A and B take to complete this work if they start working together? So, whenever the question is given like this, if they start working together, if 2 or more persons start working together, always you have to consider sum of their 1 day work, right? So here are 2 persons. So A plus B. Here A represents A's 1 day work, right? 1 day work. B represents B's 1 day work. B's 1 day work. So in scientific terms, we call it as efficiency. Since we all know that work is equal to efficiency into time. as we have discussed in the previous questions. So efficiency into time. Therefore, efficiency, here efficiency is nothing but 1 day work, right? Is always total work W by time taken to complete that work, right? Here, so we need to find time taken by A and B to complete the total work if they start working together. Therefore, A and B, their efficiency, sum of their efficiency is always total work divided by time taken to complete the total work. Right? So this is how you can calculate number of days taken by A and B. Right? How many days would A and B take? So this is how you have to calculate. For that, we need total work and sum of the efficiencies or sum of 1 day works of A and B. Right? Let us go one by one. Here it is given that, so for first 5 days, right, A completes some portion of work. Let W1 be first portion of work completed by A in 5 days. And after 5 days, B starts working and B worked for 21 days. B worked for 21 days to complete remaining work, let it be W2. Right? And it is given that A can do a piece of work in 40 days. Right? So in ideal condition, if A alone is doing that particular work, A can do a piece of work in 40 days. Therefore, work is equal to, if A alone is doing, so it is equal to sum of efficiency or 1 day work of A into 40 days. Therefore, 1 day work of A is always total work W by 40. Right? Here we need, so time taken by A and B together, right? If they start working together. So here we have got efficiency of A. So what is efficiency of B, right? So consider the second portion of work, right? So W2 is equal to, here W2 is remaining work. It is total work minus first part of work. Total work minus W1. Here total work is W minus W1, right? Here W2 amount of work has been done by, I'll write here, by B in 21 days. If you consider this formula, W2 becomes B into 21. Right? So here W is, we'll write W as it is minus W1 is work done by A in 5 days. So we'll write it as A into 5 days. Efficiency into time. A into 5 days. Right? What is A? 1 day work of A, which is W by 40. Right? Therefore, W minus A is W by 40 into 5. 5 into 8. Therefore, W minus W by 8 is 7W by 8 is the remaining work. 7W by 8 is the remaining work. Right? So, what do we need here? B. Right? Efficiency of B. What is efficiency of B? Efficiency of B is W2 by 21. W2 by 21. Therefore, 1 day work of B. 1 day work of B is W2 by 21. Since W2 is 7W by 8 out of 21. Right? So, 7W by 8 into 21, which is W by 24. W by 24 is 1 day work of B. So once we know the value of A and B, so which is total work by time taken, right? We'll consider A plus B. If they start working together, right? Sum of their efficiency, sum of their 1 day work becomes A plus B, W by 40 plus W by 24. Here 120 is the LCM. So 40 into 3, therefore it becomes 3W, 24 into 5. So we have 8W by 120. So it is 1 day work of A and B, right? When they are working together. So 1 day work is always total work by time taken. Here I'll write 8W by 120 as 1 W by 120 by 8. So it is 8 into 1, 8 into 5. W by 15 is the answer, where W is the total work, 15 is the time taken. Therefore, A and B together they take 15 days of time, right? 15 days of time to complete W amount of work. So option A is the right answer. Question 29. 14 persons can do a work in 27 days. After 9 days, they were joined by 7 more persons. The remaining work will be completed in. So here students, for first 9 days, right? For first 9 days, 14 persons, right? So will work, right? After 9 days, 7 more persons will join, right? Them. So that means number of persons will be 14 plus 7 persons, 21 persons, right? So to do the remaining work, so remaining work will be completed in how many days? So T number of days, remaining work will be completed, right? If W1 is first part of the work, W2 is the second part of the work. So W1 plus W2 becomes the total work, right? Total work. So what is the total work here? So it is given that 14 persons can do a work in 27 days, right? So totally they take 27 number of days. Here students, we are using the concept of work, which is efficiency into time, or 1 day work. Work is always 1 day work into time, or efficiency into time, right? So 14 persons indicates number of persons or their efficiency, how many are working, right? So in other words, 1 day work is considered as efficiency into time. So efficiency means if there are 14 persons, right, they'll take 27 days to complete the total work. Therefore, total work is equal to 14 into 27, right, is equal to, right? In ideal condition, it is 14 into 27. But in this particular condition, right, 14 persons, they work only for 9 days, not for 27 days. They work only for 9 days. Therefore, first part of the work, W1, becomes number of persons into 9 days. Plus second part of the work, W2, becomes, so 21 workers, 21 persons, they work for how many number of days? T number of days, right? Simplified, 14 into 27, no need to find the product here. So we'll directly take 21T as 14 into 27 minus 14 into 9. Since 14 is common here, so into 27 minus 9 is 18. 14 into 18. Therefore, T is equal to 14 into 18 by 21, right? So 7 into 2, 7 into 3, 3 into 6 is 18. Therefore, so in the second part of the work, right, they take T number of days, which is 12 days time. The remaining work will be completed in 12 days. Option B is the right answer, right? First part of the work has been done in 9 days by 14 persons, whereas second part of the work, right, this has been done by 21 persons in 12 number of days. Option B is the right answer. Question 30. If Tushar completes 2 by 7th part of a work in 6 days, then what part of the work does he do in 1 day, right? So work is always 1 day work into number of days, right? So the total work, if you consider in general, total work is always 1 day work, 1 day work into time or number of days. How many days that particular person took to complete the total work, right? So 1 day, his 1 day work into number of days taken by him. Here, Tushar completes 2 by 7th part of work in 6 days, right? So if you consider the work as 2 by 7th, right? 2 by 7th part of total work is equal to 1 day work of Tushar, right? 1 day work of him into, right, how many days he took to complete 2 by 7th part of work? He took 6 days of time. In 1 day, if he can do some amount of work, right? Therefore, in 6 days, therefore it is into 6 days. So in 6 days, he can complete 2 by 7th part of work. Here the question is, what part of the work does he do in 1 day? Therefore, his 1 day work. His 1 day work is always 2 by 7th part of work, right? 2 by 7th part of work divided by 6. Or you can write it as 2 by 7 into 6, right, of total work. Right? So since 2 into 3 is 6. So he can do 1 by 21 part of work, or 1 by 21st part of work in how many days? In 1 day. Right? So he can do 2 by 7 part of work in 6 days. Therefore, in 1 day, he can do 1 by 21st part of work. So option D is the right answer. Question 31. 25 men with 10 boys can do in 6 days as much work as 21 men with 30 boys can do in 5 days. How many boys must help 40 men to do the same work in 4 days? Right, here the question is 25 men, right, with the 10 boys means plus 10 boys, right, can do some amount of work in how many days? In 6 days. In 6 days. Right? So can do some amount of work. We all know that work is always efficiency into time. So here in this particular case, efficiency means capacity, right? What is the capacity? What is the strength of the person, right? It depends on that. So 25 men plus 10 boys. This is the capacity or efficiency. Capacity. In how many days they can complete the work? So in first case, 25 with 10 boys can do in 6 days, right? In 6 days. So number of days or time into capacity gives the total work, right? Therefore, so 25 men plus 10 boys can do it in 6 days, right? So to do the same work, 21 men with 30 boys can do in 5 days, right? So same work can be done by 21 men with 30 boys. In how many days? So capacity into time or number of days. In 5 days, right? 21 men with 30 boys. In 5 days, they can consider or they can do the same amount of work, right? Therefore, can we equate both LHS part, right? Therefore, 25 men plus 10 boys in 6 days into 6 is equal to 21 men plus 30 boys in how many days? In 5 days into 5. Right? Here what to be calculated here? How many boys must help 40 men to do the same work in 4 days? That means how many boys? Dash number of boys, or you can consider as X boys with 40 men in how many days? Into 4. Into 4 days is the total work, same work, right? To consider value of X, number of boys, we need the total work. What is the amount of total work here, right? For that, to find total work, we need to consider what is the relation between number of men and number of boys. That means one man is equal to how many boys? That we need to find. Right? Then you can easily find the total work. So either using first equation or second equation. So you can easily consider the total work, right? So let us find the relation between man and boy. That means one man is equal to how many boys, right? For that, consider these two LHS parts which are equated. So 25 into 6 is 150 men plus 6 into 10, 60 boys is equal to 21 into 5, 105 men plus 150 boys. Therefore, 150 men minus 105 men is equal to 150 boys minus 60 boys. Right? Therefore, 45 men is equal to 90 boys. Therefore, one man is equal to 90 by 45 boys. So, which is nothing but 1 man is equal to 2 boys. Right? 1 man is equal to 2 boys. Right? So either you can consider equation 1 or equation 2. Right? Since 25 men plus 10 boys into 6 is the total work. Therefore, equation 1 becomes, so we'll consider total work. Right? We are finding total work is equal to 25 men. So here 25 men is given. So 1 man is 2 boys. Therefore, 25 men becomes 25 into 2 boys. Plus how many boys? 10 boys into 6 days. 10 boys into 6 gives the total work. Therefore, 25 into 2 is 50 plus 10, 60 boys into 6, which is 360. So, total work is 360 units. Right? This is the total work. Here the question is, how many boys must help 40 men to do the same work in 4 days? So, we'll consider this part. So, X number of boys, right? X number of boys along with 40 men. 40 men means 40 into 2 boys. Boys in how many days? In 4 days can do the same work. Here the amount of work is how much? 360 units. Right? 360 units. Therefore, so we'll simplify it. X number of boys plus 40 into 2, 80 boys into how many days? Into 4 days is equal to 360. Therefore, X boys plus 80 boys along with 80 boys. So, is equal to 360 by 4, which is equal to 90. Right? Which is equal to 90. So, X boys plus 80 boys is 90. What is the value of X? Therefore, value of X is equal to 10. Right? X is number of boys in the, so number of boys must help 40 men. 40 men in the sense 80 boys. Number of boys must help 80 boys to do the same amount of work is 10 boys. Option B is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question 32. Sneha is 43% more efficient than Mansi. Find the time taken by Mansi to do a certain work, which Sneha alone can do in 10 days. So here, time taken by Mansi to do a certain work. So if you consider work done by Mansi, right? So Mansi to do a certain work, which Sneha alone can do in 10 days. So work done by Mansi is equal to work done by Sneha in 10 days. Work done by Sneha in 10 days. Right? So we all know that work is always efficiency into time. Right? So if you consider work done by Mansi, so it is efficiency, her efficiency into time taken by Mansi to complete that work is equal to work done by Sneha. So it is Sneha's efficiency, right? Efficiency of Sneha into time taken by her is 10 days, right? Here we need to find time taken by Mansi. So find the time taken by Mansi to do a certain work. This, for that we need efficiency of Mansi, also efficiency of Sneha. It is given that Sneha is 43% more efficient than Mansi. Right? Therefore, we can write efficiency of Sneha is equal to 143% of efficiency of Mansi. Efficiency of Sneha is 143% of efficiency of Mansi. Right? Because Sneha is 43% more. Right? So if 100 is the efficiency of Mansi, Sneha's efficiency becomes 143, right? Therefore, efficiency of Sneha is 143% of efficiency of Mansi. So if you consider X as efficiency of Sneha, right, which is equal to 143% of, we'll consider Y as efficiency of Mansi, right? Keeping this in our mind, right? So here what to be calculated? So time taken by Mansi, right? So for that we need to express efficiency of Mansi in terms of so efficiency of Sneha, or efficiency of Sneha in terms of efficiency of Mansi, right? Both are same. Here efficiency of Sneha is 143% of Y, right? 143% into Y into number of days taken by Sneha is 10 days, which is equal to efficiency of Mansi. Efficiency of Mansi is Y into time taken by her, right? Therefore, time taken by Mansi is equal to 143% means 143 by 100 into Y divided by this Y, right? Y into 10, right? So 10 into 10 is 100. So 143 by 10 is 14.3, right? Here Y and Y will get cancelled. So time is equal to, so 14 integer 3 by 10 days. So who takes 14 integer 3 by 10 days? So time taken by Mansi. Mansi takes 14 integer 3 by 10 days to complete the certain work which Sneha alone can do it in 10 days, right? So, but Mansi takes 14 days, 14 integer 3 by 10 days. So option B is the right answer. Question number 33. To do some work, A takes 10 days more than B. B takes 15 days less than C. Here is a small correction. Here D is 50% more efficient than C. It should be D is 50% more efficient than C, and D takes 50 days individually to finish the work. So D takes 50 days individually, right, to finish the work. In how many days can they do the work if they work simultaneously? So students, it is given that A takes 10 days more than B. So we'll consider B takes T days, right? So if B takes T days to complete the work, then A takes T plus 10 days, right? T plus 10 days. And it is given that B takes 15 days less than C. So if B takes T days, then C takes T plus 15 days. That means C takes 15 days more than B, right? Vice versa. So here C takes 15 days more than B means C takes T plus 15 days. And it is given that D is 50% more efficient than C. That means D's efficiency of D is 150% of efficiency of C. Efficiency of C. Right? D is 50% more efficient than C, means efficiency of C plus 50% efficiency of C. That gives 150% of efficiency of C. Right? So here D takes 50 days. So to complete the work, D takes 50 days of time. Right? So the number of days that A, B, C take, how to find that? It depends on efficiency of D and C. Right? Based on this, we'll find number of days taken by C based on the efficiency. We know that efficiency is inversely proportional to time. If person is more efficient means he takes less time, right? Efficiency is inversely proportional. More the efficient, less will be the time. So less the efficient, he takes more time, right? Therefore, we'll consider efficiency of D to efficiency of C ratio. It is 150 by 100, right? That is 3:2. Their efficiency ratio is 3:2. That means time taken by them, time taken by D to C is 2:3, right? They are inversely proportional. Therefore, time taken by D to time taken by C is equal to 2:3. right? Here time taken by D is given 50 days. Therefore, time taken by C is equal to time taken by C is equal to time taken by D into 3 divided by 2. Time taken by D is 50 days into 3 by 2. So which is 25 into 3, 75 days. So that means C takes 75 days. So here T plus 15 is, so we'll consider that part. T plus 15 is equal to 75 days. Therefore, T is equal to 75 minus 15, which is 60 days. So B takes 60 days of time, right? Whereas T plus 10 is 70 days. A takes 70 days of time, right? So based on number of days they took, so here we have to consider the question. In how many days can they do the work if they work simultaneously? If they work simultaneously means first we'll consider their one day work, right? So let us consider, let total work be W. Total work is equal to W, which is nothing but one day work of A, one day work of A plus B plus C plus D is equal to total work divided by total number of days, total time or total days. Based on the concept of work, total work is one day work into total number of days, right? Therefore, one day work of A, B, C and D, their total one day work is equal to total work by total days, right? So we'll consider one day work of A, B, C, D, right? So one day work of A is total work by 70, right? So it becomes W by 70 plus one day work of B is total work by B takes 60 days of time. It is 60. And C takes how many? So C takes 75 days, right? Is it 75? So time taken by C is 75. Yes, 75. And D takes 50 days of time. So their one day work is equal to, so we have expressed in terms of total work by total days. Therefore, their one day work becomes, here LCM is 2100. LCM of 70, 60, 75 and 50 is 2100, right? And the numerators become, so here it is 30 into 70, right? 70 into 30 is 2100. So numerator becomes 30W. Since 16 to 35 is 2100, so numerator becomes 35W. So 75 into 28 is 2100, numerator becomes 28W. And 50 into 42 is 2100, so numerator is 2100. Sorry, 42W. So together we'll get 135W by 2100. So we'll express in terms of total work. So W by 2100 by 135. Right? 2100. So here W is the total work. Total work. 2100 by 135 is time taken. Total time taken by A, B, C and D. Right? What is asked in the question? So in how many days they can do the work if they work simultaneously? So total time taken by them is, therefore, time taken by them A, B, C, D, right, is equal to 2100 by 135 days. Simplify it, right? 2100 by 135 is equal to, so 135 into 1. So you have 5, then 7. So 75 as the remainder. Then 135 into 5, you can try, right? So 5 into 5, 25. So 17, so 675, right? 675. So you have 5, so 55, right? 55 as the remainder. Am I right? Or 5? So I think 750. Yes, 750, 675. So here, yes, 75 is the remainder. Sorry, 75 is the remainder. So here you get 15 integer. So 15 integer, 75 by 135. Right? Still you can simplify. 75 by 135 can be written as. So 5 into 1, 5 into 5. And 5 into 2, 5 into 7. Right? Again, 3 into 5 is 15, 3 into 9. So the time can be written as 15 integer 5 by 9. Right? 15 integer 5 by 9 days. So A, B, C, D together they take 15 integer 5 by 9 days to complete the work. Hence option B is the right answer. Question 34. Working alone, A, B and C can do a work in 13, 17 and 19 days respectively. How long will they take if they work together? So if they work together, so what is their 1 day work? Right? So 1 day work is always total work by time taken by them. So according to the concept of work, total work by total time is 1 day work. So we'll consider 1 day work of A, B, C, right? A plus B plus C means if they work together, right? Their 1 day work. So here A can do a work in 13 days individually. Therefore, if you consider W as the total work by number of days gives his 1 day work, right? W by 13 is A's 1 day work plus W by 17 is B's 1 day work plus W by 19 is C's 1 day work is equal to, if you consider W as the total work, so and time is capital T. W by T is total work by total time, right? Simplify it. So here LCM is 13 into 17 into 19, right? And the numerators become, so 17 into 19W plus 13 into 19W plus 13 into 17W is equal to total work by total time. We'll simplify it, right? Here, we'll take out W as common. 17 into 19 is equal to 323 plus 13 into 19, 247 plus 13 into 17 is equal to 221 whole divided by 13 into 17 into 19, right? Into 19, you will get 4199 is equal to W by T. So we can cancel W and W. So we have T is equal to 4199 divided by sum of these three values, right? So 323 plus 247 plus 221. So 791. So 791 into 5 is 3955. So it becomes 5 integer, right? So 3955. So 41999 minus 3955 gives, so 244 is the remainder. So 5 integer 244 by 799 number of days. They work for all A, B and C. If they work together, they work for 5 integer 244 by 791 days to complete the whole work, total work W, right? So get the options. Option D is the right answer. Question number 35. Working 7 hours daily, 24 men can complete a piece of work in 27 days. In how many days would 14 men complete the same piece of work working 9 hours daily? Here students, work in this particular question. So we all know that work is efficiency into time, right? Here we'll consider the capacity. Efficiency or capacity, both are same. Capacity in the sense how many people are working here. into different conditions, right? Here work is equal to capacity into time or efficiency into time, right? So in first case, 24 men, right? They work for 27 days. Here capacity is 24 men into 27 is they work for 27 days. But for each day they work for 7 hours. Therefore, for 27 days, right? 27 into 7 gives the total hours, right? So here the time is nothing but 27 into 7. So is equal to the total work. Total work. If same amount of work has been done by 14 men, right, and 9 hours daily if they work, so how many days they take? Therefore, we can equate this 24 into 27 into 7, which is total work, with 14 men, right? How many hours they work per day? 9 hours into number of days, let it be D, right? So this gives the total work done by 14 men, right? Which is also equal to 24 into 27 into 7. Since in both the scenario, both the conditions, work done is same piece of work, right? Therefore, so how many days they'll take? How many days these 14 men will take? So D is equal to 24 into 27 into 7 divided by 14 into 9. Right, 7 into 2 is 14, 2 into 12 is 24, and 9 into 3 is 27. So 12 into 3 we have, so 36, right? The unit is days. So 14 men take 36 days to complete same amount of work, and they work for 9 hours daily, right? Hence option C is the right answer. Question 36. 33 integer 1 by 3% of a man's daily output is equal to 50% of a second man's daily output. If the second man turns out 1500 screws daily, then first man's output in terms of making screws is. So we'll consider two persons A and B, right? Or their output, right? As A and B. First man's output as A, first man's output as A, and second man's output as B, right? It is given that 33 integer 1 by 3% of first man's output. So 33 integer 1 by 3% of A is equal to 50% of second man's output. Second man's output is B here, right? 50% of B, right? And it is given that second man's output turns out 1500 screws daily. So you can make 1500 screws. So that means value of B is equal to 1500, right? His output is 1500. Therefore, 50% means 50 by 100 into 1500. So half of the 1500, right? Which is 750, right? 750. So 33 integer 1 by 3% of A means 33 into 3 plus 1, right? So which is 100 by 3% of A is equal to 750. Here what is to be calculated? First man's output, value of A should be calculated, right? So simplify it. So here 100 by 3% means 100 by 100 into 3, right? So it is 1 by 3 into A is equal to 750. Therefore, value of A is equal to 750 into 3. So you will get 2250, right? So output of first person is 2250 screws, right? Therefore, option D is the right answer. Question 37. A and B can do a work in 3 days. B and C can do the same work in 4 days. C and A can do it in 12 days. Find the time taken by them if they all work together. So if you want to find the time taken by, if they start working together, so you need to find their individual capacity or individual efficiency, right? Since work is equal to efficiency or capacity into time, so we'll consider the capacity of these three persons, right, is equal to work by time, W by T. Right, here it is given that A and B can do a work in 3 days, right? That means A's capacity plus B's capacity is equal to the total work W in how many days? 3 days, W by 3, right? Whereas B plus C, B's capacity plus C's capacity in the sense the work done per unit time, right, or their 1 day work, right? B plus C is equal to total work by number of days, so they took 4 days of time to complete the total work, whereas C plus A can do it in 12 days. C plus A is W by 12. So we need to find time taken by them if they all work together. If they all work together means, so A plus B plus C, their 1 day work, if they start working together, sum of their capacity becomes their 1 day work, right? So it becomes W by total time, work done by total time. So we need to find this total time. For this, we need their individual capacity, right? So by considering these relations as equation 1, 2, and 3, right? So we'll consider equation 1 minus equation 2, right? So that we can delete B here, right? So here A minus C, equation 1 minus 2 gives A minus C in the LHS. So W by 3 minus W by 4. Since LCM is 12, so 4 minus 3W is W. W by 12 is A minus C, right? So here we have A plus C as W by 12, right? Also C plus A or A plus C. A plus C is equal to W by 12, right? Simplify it. Therefore, if you consider this as, equation 4 and 5, two simultaneous linear equations. So we have 4 plus 5 gives. So you can delete C here. 2A becomes 2 times capacity of A becomes 2 times W by 12, right? Therefore, value of A, capacity of A is equal to W by 12. If 2 times A is 2 times W by 12, A capacity of A is W by 12, right? Now capacity of B, substitute this in any of the equations, right? A is W by 12. Therefore, from equation 1 becomes capacity of B is W by 3 minus A. A is W by 12. So we have 12 as the LCM, 3 into 4. So 4W minus W is 3W. So capacity of B is W by 4. Right, which is important. W by 4 is capacity of B, whereas capacity of C. So from equation 2, B plus C is W by 4. Right? So W by 4 plus C is W by 4. So capacity of C is 0. Right? That means C doesn't do any work. Right? So C doesn't have any capacity to do work. Therefore, if all of them start working together, so we'll consider their individual capacity A plus B plus C is equal to total work by time, total time, right? So A is W by 12, just now we had calculated, plus what is the capacity of B? B is W by 4 and C has 0 capacity is equal to W by T. So we have 12 and here 12 is the LCM, 3W plus W, so 4W is equal to W by T. So we can cancel W and W. Therefore, T is equal to 12 by 4, which is 3. Right? Here the unit is days, I think. Right? T is equal to days. So if all of them start working together, they take 3 days of time to complete the whole work W. Right? Therefore, option B is the right answer. Question 38. A civil engineer fixed a schedule to finish a certain project in 360 days with the help of 90 workers. After 90 days of work, he employed 90 more workers in order to finish the work before time. Find the number of days saved. So here the engineer fixes schedule to finish project in 360 days with the help of 90 workers. Here his plan was to complete the total work, so which is efficiency or capacity into time. Here capacity is nothing but number of workers working here, right? So he hired 90 workers. Capacity is 90, right? His plan was, right, to complete the project in 360 days. Here time is 360. This is the total project, right? That means total work. But after 90 days means in first part of the work. So 90 workers, they work for 90 days, first 90 days. After 90 days, he employed 90 more workers. That means 90 plus 90 workers start working. 180 workers, they work for how many days? D number of days to complete this work, 90 into 360 units of work, right? Therefore, we can write total work as first part of the work W1 plus second part of the work W2. Here the total work is 90 into 360 is equal to part of the work is 90 workers. They worked for 90 days. Capacity into time. Plus in the second part 180 workers. They have to work for D number of days. We need to find this value of D. Time taken, right? So time taken by 180 workers in the remaining part. Here the question is find the number of days saved. Number of days saved, right? So here, according to his plan, it was 360 days, right? So here we need to consider 90 plus how many days actually they took, right? So minus the time taken in actual case. This gives time or number of days saved, right? Number of days saved. So for that, we'll take this part. Total work is equal to 90 into 90, 8,100 plus 180 into D. So 90 into 360 will calculate it. 180D is equal to 90 into 360. So what is the value? So 9 into 6, 54. 9 into 27 plus 5 is 32. 32,400 minus 8,100. So we have 4 minus 1, 3, 12 minus 8, 4. Yes, 24,300. And value of D, 24,300 by 180. So that we can cancel 0 and 0. 18 into 1, then 18 into 3, 54. 18 into 5. So D is equal to 135 days. In the second half, in the second part of the work, they took 135 number of days. Right? So find the number of days saved. So we'll check whether this option is given in the given 5 options or not here. Actually, they took 135 days to find number of days saved. Saved days are, according to his plan, so he could complete the project in 360 days minus, actually they took 135 days plus 90 days, right? So it is 225, right? 225 days. So 10 minus 5 is 5. So 5 minus 2 is 3 and 3 minus 2, 1. Yes. So saved days are 135 days, right? So by adding 90 more workers in the second part of the work, they could save 135 days, right? Therefore, option D is the right answer. Yes, the option is given already. So option D is the right answer. Question number 39. A, B, and C complete a piece of work in 20, 12, and 18 days respectively. They start the work together, but A drops after 4 days and B drops out 2 days before the completion of the work. The work is finished in. So students, for first 4 days, all A, B, and C, they work together, right? So A plus B plus C, they work for first 4 days, right? After 4 days, A drops out, right? That means B and C will be continuing, right? So they work for n number of days. They work for n number of days, and B drops out 2 days before the completion of the work. So that means, so last 2 days only C will be working, right? For last 2 days, because B drops out 2 days before the work got finished, right? So only C will be finishing the work in 2 days, right? The remaining work will be finished by C in 2 days. So here the question is, the work is finished in. So the total work is finished in. So the total time, 4 days plus 2 days plus n number of days, right? So that we need to find. So total time. So what is the total time taken to finish the work? For that, we'll consider total work to be done as W. If you consider total work to be done as W, right? Here for first 4 days, A, B, C. So what amount of work will be done by A, B, C in first 4 days, right? So here, 1 day work of A, B, C. We'll consider their 1 day work. So we'll consider A, B, C like this, right? Their 1 day work. 1 day work. A is 1 day work is total work by time taken by A. So W by 20 amount of work done by A. Because A takes complete 20 days of time to complete the work, right? So individually A takes 20 days time. So A's 1 day work is W by 20, whereas B's 1 day work is W by 12, right? So whereas C's 1 day work is W by 18, right? But A, B, C, they work for 4 days together, right? Their 4 days work. Each one's 4 days work becomes 4 into W by 20, right? So 4 into W by 20 means 4 by 5, right? Then 4 into W by 12, right? So 4 into 1 day work becomes W by 3, right? And C is 4 days workers. So C work only for 4 days, right? First 4 days. So here C's 4 days work means 4W by 18, which becomes 2W by 9. 2W by 9. C's 4 days work, right? So here students, ABC work for 4 days. So their total 4 days work. So A plus B plus C's 4 days work. 4 days work is equal to, so W by 5 plus W by 3 plus 2W by 9, right? So it is W by 3, 2W by 9. So here LCM is 45, right? 45 is the LCM. So 9W plus 15W plus, so 9 into 5 is 45. So 2 into 5 becomes 10W. So their 4 days work becomes 25 plus 9. It becomes 34W by 45 is their 4 days work, right? And for n number of days, right? So n number of days, B and C work together, right? So B and C's n days work. N days work is equal to B's 1 day work is W by 12, C's 1 day work is W by 18. So W by 12 plus W by 18, right? Into n number of days. 1 day work into n gives n day work, right? Since LCM is 36, numerator becomes 12 into 3 is 36. So 3W plus 2W, it becomes 5W into n, right? 5W into n by 36 is B and C's n days work. Whereas 2 days work of C. So 2 days work of C. C's 1 day work is W by 18 into 2 gives W by 9. W by 9 is 2 days work of C. So total work is W. So we'll add all these works. 4 days work, n days work and 2 days work. right? So the sum is equal to total work, so that you can easily find the value of n, right? N days. Therefore, so 4 days work plus n days work plus 2 days work, last 2 days work is equal to total work. Total work. So substitute the values. 4 days work is 34W by 45. 34W by 45. And n days work is, so 5WN by 36, right? 5WN by 36 plus last 2 days work is W by 9 is equal to total work, right? So we'll consider first and the last work, right? 4 days work and 2 days work. It is here 45 is the LCM, 34W plus, so 9 into 5 is 45, so it becomes 5W plus 5WN by 36 is W. Therefore, so 5WN by 36 is equal to W minus this term, 34 plus 5 is 39 by 45W, right? So it becomes 45 minus 39W is 6W by 45, just divisible by 3. So 3 into 2, 3 into 15, right? 2W by 15. So value of n becomes 2W by 15 into 36 by 5W, right? W and W will get cancelled. So we have 36 into 2, 72. And 15 into 5, 75, right? 72 by 75 as value of n. So it is divisible by 3, right? 3 into 24, 3 into 25. 24 by 20, so 24 by 25 is value of n, right? 24 by 25, value of n. So here, the total work is finished in. So what is the total time? 4 days plus 2 days plus n days. So total time is 4 plus 2. Total time is 4 days plus 2 days plus n days. So 6 plus n is 24 by 25. Since LCM is 25, so we have 25 into 6, which is 150 plus 24, right? Which is 174 by 25. So 25 into 6 is 150. So remainder is 24. So 6 integer 24 by 25 is the number of days, total number of days, right? So total time is 6 integer 24 by 25, right? So here option B is the right answer. There is a slight correction in option B. It should be 24 by 25. 6 integer 24 by 25. Option B is the right answer. Question number 40. Drishti completed her assignment in 37.5 days, whereas Payal completed the same assignment in 25 days. Find the time taken by them to complete both the assignments working together. So here, students, individually, they take 37.5 days and 25 days to complete their assignment, right? So here, to complete both their assignments, that means, so first they have to, if they are completing Drishti's assignment, right? So together they have to complete their assignment, Drishti and Payal. Together they have to complete Drishti's assignment. So what is the number of days they are taking to complete that? After that, they have to complete Payal's assignment, right? Right? Working together. By working together, how many number of days they will take if they work together, right? Therefore, total time taken by them. So, number of days taken to complete this Drishti's assignment plus Payal's assignment. So, what is the total time taken by them? That we have to find, right? Here, to completing assignment, we'll take it as the total work, right? So, total work, let it be W, right? So, here, total work is nothing but completing assignment. Completing assignment. To complete this work, Drishti takes 37.5 days, right? Therefore, 1 day work of Drishti is equal to, so total work by 37.5 days. So which is equal to 37 into 2, it is 74, plus 1 is 75. 75 by 2, so W by 75 by 2 means 2W by 75. So in 1 day, Drishti can do 2W by 75 amount of work, right? Right? Whereas 1 day work of Payal. 1 day work of Payal. So Payal takes 25 days, right, to complete one assignment. Therefore, to come in 1 day, she can complete W by 25th part of the assignment, right? Therefore, if they work together, right, their 1 day work becomes sum of their 1 day work, 2W by 75 plus W by 25. Since 75 is the LCM, so numerators become 2W plus 3W. So it is 5W by 75 or W by 75 by 5, right? W by 75 by 5 is 13, right? 13. So to complete the total work, one assignment, right? Total work is one assignment here. So they take 13 days of time, right? So total time is 13 days here. But the question is, so to complete both the assignments, right? To complete two assignment, right? So for one assignment, they take 13 days. Therefore, for two assignments, they take 13 into 2, which is 26 days. So it is not 13 days actually. So 15 days. 15 days. So for one assignment, they take 15 days. So together they take 30 days of time. Sorry, here 75 by 5 is 15 days, right? So for two assignments, they take 30 days of time, right? So here option C is the right answer. Students, if you want to practice such questions on time and work, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you a very best of luck for your future exams.